and that I paid for that $1,500. And this is again less than $100. And of course the Arduino, which I designed some years ago, which combines VNA, spectrum analyzer, everything all together, which is again, fairly cheap to make yourself. So the test instruments are now available for you to be able to go to VHF. Now, traditionally, people have challenged themselves to build VHF on their own. So this actually set here is a Heathkit. It's called Goner set. This launched VHF for a lot of radio hams in the 60s. It used a lot of World War II surplus material. That was one. This is actually a favorite of old-time satellite operators, IC-202. It's an SSB only rig. And this is David Campbell's phasing receiver, analog phasing receiver. And I don't know if you remember this, in the 80s handbook, this picture was there of a super regenerative VHF set. Anyhow, this is just a perspective. Okay. This here is the original BitX circuit diagram. If you see here, you see this and that, that and that, and that and that. They are exactly the same circuit which was used over and over again. So if you understood, hello? Poindi. चले यार बस हाँ सुलगाओ कुछ करो पावर चलेगा शायद इधर का So actually the BitX used only two circuits, two one transistor circuit diagrams. One was an amplifier, the other was an oscillator. So if you actually look closely at this oscillator, there are two capacitors, one transistor like this, one transistor like this. If you see this also, the same thing, two transistors, two capacitors, right? Here there is a coil and a capacitor. Here there is a filter and a coil. So I tried reusing the same thing because I understood only these two circuits, and we built the entire thing out of this. And if you look at the block diagram is approximately like that. Band pass filter, RF amplifier, mixer, IF amplifier, crystal filter, second IF amplifier, detector. Okay, I'll just skip through this. Now, this can be actually simplified. So here I have removed the RF amplifier, I have removed the second IF amplifier. Not required at all, because there is enough gain even otherwise. So, two stages, which means 4 amplifiers have been actually eliminated from this. The oscillator, free running oscillator, has been replaced by an SI570. You can also use SI5351. 5351 is a little difficult for homebrewers to solder, but the SI570 is very easy to solder. But how does it perform even without these, after removing so many things, right? You have basically given it a haircut. You just removed too many components, but will it still work? So the best way is to do a calculation, and this is the calculation here. So band pass filter, you lose 2 dB, minus 2 dB. Mixer is a passive diode mixer, minus 6 dB. Then we have an amplifier with 15 dB gain. And then you have a crystal filter with minus 10 dB gain. It's a very high loss filter, and I'll tell you why it's high loss later on. Then detector directly, another diode mixer, minus 7, and audio amplifier. So if you see this, the noise figure is still 15 dB, which is perfectly fine for all HF work. The dynamic range is very good actually, it's 96 dB. Above 90 dB is supposed to be good, but this is going to 96 dB. So it is actually a fairly good radio by any stretch of imagination. And this is the entire circuit diagram. That's all there is to it. So if you see this circuit diagram as compared to, let me quickly go back here, that, right? You see this? And then I'll come back and show you this. So it's much simpler. You have the diode mixer there, and the SI570, down converting or up converting, whichever way. Then IF amplifier, crystal filter. If you see this crystal filter, instead of 4 crystals, now there are 8 crystals here. directly going to the detector and then audio preamplifier going like this way, and bidirectionally this is the mic amplifier. Okay, now there are a couple of things here. One is that this mic amplifier has an emitter follower, because the original mic amplifier had 1K output impedance, but the diode required 50 ohms. So to make that thing, to make the matching, one extra transistor has been added. Transistors cost only 50 paise. Earlier, we still have the valve mentality where the moment you put an active device, you think the price is going up, but the price only goes up by a couple of rupees. Then what we did here is we switched from Arduino to Raspberry Pico. The Raspberry Pico is about probably 20 times as good as that. It's an ARM 32-bit processor instead of an 8-bit processor. It's got 128K RAM. So, you don't have all those limitations at all. So that is the thing. And you see here, I have not included any RF here at all, design from the IF output. That is because this crystal filter is at 27 megahertz. And at 27 megahertz, to make it narrow enough for it to become an SSB filter, will have a lot of high loss, which is why in our calculations here, you see this crystal filter loss is minus 10 dB. Because the narrower you make the crystal filter, the higher are the losses. And this is what it looks like. It's very small, as you can see. The pencil is there for you to just take a idea of it. And this is the entire exciter. This is all the complete exciter. There is the SI570. This is the mixer. So the RF comes in here. And then these are the two IF amplifiers, crystal filter, and this is the audio section. As you can see, the audio section is very compact, because I started building it from there, then I didn't have enough space here. So everything just got congested in the end. And behind this, if you flip this around, underneath this is the digital part. So the digital part here is under it. Okay, I have it here with me. You guys can take a look at it. And that's a Raspberry Pico here with a 5-volt regulator. And what we have done is, they usually create a lot of noise, the digital one. So this ground plane is different from the ground plane of the analog part, which is this. There are two separate ground planes, okay? And between them, there should be only one contact between the two. So if you see here, there's a jumper going from here to the other side. So there should be only one connection between the two, and that's how you eliminate the digital noise. Okay, now how do we make it into VHF? Okay, so I'm very bad actually at making presentations, so this is what it is. If you see on the top, the coil capacitor makes a resonator, right? So what you do is you couple energy from one to the second to the third, as you can see on the top. So how do you couple it? By adding those capacitors, right? But when you do that, the impedances, the input and output impedances are what determines the bandwidth. So to match it down to 50 ohms, you basically have to tap on the capacitance. So this is a tap on the capacitance, and this is the final version. But this version is not very different from there. If you see, it's the same evolution of the same design from top to bottom. That's number one. Number two, how to get gain at VHF. So that's fairly simple. There are these mimic chips. This is AG30386. It's about 50 cents, about 50 rupees worth of chip. And it works all the way to 3.5 gigahertz with substantial gain there. And the design is very simple. There is an input and output, and you just give it some power through a choke. That's all it takes. It's extremely stable. It does not oscillate. So when you're picking up these mimics, look for the mimics which are called unconditionally stable, meaning they will never oscillate, however badly you behave with them. So this is the same filter which I had talked about here. This is the same filter, and I actually use a simulation software here to find out how well it will work and how is, yeah, this is 145 megahertz, which is my center frequency. And as you can see, it's going to be very sharp with minus 90 dB out of band rejection. But if you see on the top, I mean, each of this is 10 dB. It's about 4 dB loss. So the loss is substantial, and it's substantial especially for VHF, where you require very, very low noise. So what you do is, this is how the VHF front end is made. So there's a band pass filter here, and because the band pass filter is very lossy, what you will do is on receive, you go through a low noise amplifier here first. Now if you don't have this and directly feed it to the low noise amplifier, the FM broadcast will go through. So to filter it out, you have one LC, just one LC, which will not create a lot of loss, and then feed it to a triple tuned, 1, 2, 3, triple tuned band pass filter. And on transmit, you take this through one gain, second gain, and then through a power amplifier. Now the same thing can be adopted even for HF. It won't be any different at all, right? But this is a VHF version, so we just stick to that. And this is the same circuit built. You will see again the same band pass filter. First section, second section, third section, and there are shields between there. And these are all air wound coils, and I have not used any trimmers because I don't have any trimmers. So what I do is, to tune it, this is the ground end. So I basically heat the solder and catch this with pliers and pull it up and down until I get a peak. So that's how, and then you just leave it there. But this is essentially the BitX23, but you can actually make a lot of changes to it, okay? So these are the changes. I'll just talk about a couple of changes. One is, on the output here, I can add a Raspberry Pi and make it into an SDR. Okay, that's one output. The other is, I can eliminate the SI570 and replace it with a VFO. And then it will become an all analog set with very little power consumption. The third is a very interesting one. The SI570 only goes up to 160 megahertz. Okay, only up to 160 megahertz. But the diode mixer generates harmonics. So, for example, if I want UHF output at, let's say, 435. So at 435, my local oscillator requirement is 435 minus 27, 408, right? 408. SI570 or SI5351 does not go to 408. So it can actually run at 408 divided by 3. It will still give you the SSB output, okay? Except that you will require far more gain, which is fine. You just add some more of those mimics, one more mimic, and it will do it. So, then VHF won't work. Yeah. Yeah, that's for HF. Yeah. See, actually for HF, I'll tell you what to do. This is 27 megahertz IF. So here if I just put a low pass filter for 21, it will work 0 to 21 megahertz broadband. So this is the UHF part. This is a UHF version. Here, instead of using band pass filters, you get these SAW filters for 433 megahertz, very cheap, available. They are used in these car door openers, etc. They're very, small things. The 433 will work up to 435 also, no problem at all. This is the analog version. So you see there's a VFO here, and because the VFO is not being switched and directly always driving the diode mixer, you don't even require a buffer amplifier. The VFO can directly feed to the diode mixer. Okay, so this is what the current version is, and if you see, very few transistors are there. 1, 2, 3, 4, 5, 6, 7. 4 and 3. Yeah, that's it. Just 7 transistors. So it's almost half the transistors which are there in the original BitX. It's a far better performer, very stable, and because the audio preamplifier is a completely new redesigned preamplifier by W7ZOI, It's actually very, very clean. Amrendra has been using it here for his satellite work, and he's been very happy. I've never used it. Actually, I made only one QSO on this, but Amar has made hundreds of QSOs. I did a QSO with Venu one evening, just before I was going to Dayton. So that's all there is to it. If there are any questions, I'll take it. I just wanted to present this to you guys. Yeah. Pardon me? Because I have it in my junk box. Yeah. Yeah. So, okay, I'll tell you what happened. We originally used an LM380. It did not have enough gain. And as you saw on the board, I didn't have enough space. So, actually, we require one more stage of audio preamplification, and then I can put an LM380, which will be a 2-watt radio. It's also a little noisy because of this. See, the thing is, if you, between this pin 1 and 8, if you put the capacitor here, the noise increases more than the signal. So it's a bad choice, really. LM386 is not a good choice. But this is all I had. It was just one day before I was leaving to Dayton, I put it in and forgot about it. Yeah. True. Yeah. Exactly. No, this is a problem. One second problem is, Amar, that this is the 3 kilohertz wide crystal filter. We should also put a low pass audio filter, an active low pass filter or a band pass filter for CW. Then it will become a very sweet rig. Yeah, one op amp will do. Yeah, that's true. Okay, so if there are no more questions, I will. Sorry, Ghosh. Yeah. No, it's a square wave. Yeah. Square wave is actually what you need for diode, because it has to instantly switch on and instantly switch off. If it's a sine wave, it will take a little while for it to climb up to the voltage at which it will turn on the diodes, right? So actually for a diode mixer, a square wave is a far better drive than a sine wave. Okay, thanks.
Thank you, Farhan. Let's give Farhan a round of applause, please. Farhan, here's your...
Oh, thank you.
Before we have the next speaker in, a couple of announcements. There are feedback forms kept at the entrance to this hall and also at the registration counter, and we also have this with us. Please, it is a request that you fill in the feedback form, give us your honest opinion, and also suggest us ways where we can improve so that we can put it into practice. So please fill in the feedback forms and hand it over to us. Yeah, there are still a couple of pieces of SBATX at the HF Signals counter. The price that we have kept here, you will not get it anywhere else. So I would suggest, if anyone is still interested in an SBATX, to please go to the HF Signals website, stall, and pick up the units right away. Also, we have a couple of V6s, UBITX V6s still available. So if anyone is interested, please go to the LARC club counter and pick it up. In addition, we are also taking orders for V3. Many of you people have come and requested us that they want V3s, UBITX V3s. So we are taking the orders now. So if it is, we are offering it at 5,500. So 5,000 is the cost of the UBITX and 500 for the courier. So if anyone is interested, please go to the club counter, LARC club counter, and give your names, and we will send it across fully tested to your place. Before we will have the next session, I request Mr. Osama to come on stage for the next session on maker spaces. Let's give him a round of applause, please. this. You'll use this? Okay, thank you.
Thanks, Thomas. Hi, good morning, everyone. I am very new to this space and this ecosystem and the kind of audience that I'm seeing in front of me. Thanks to Farhan for torturing me to come here. So my name is Osama Manzar. I run an organization called Digital Empowerment Foundation. Sounds digital, and it used digital as a means of empowerment of the grassroots communities, villages, and all that. So in very simple line, we take internet access, computers, and IT to the places where it doesn't exist, or people do not have it. I don't know how many of you know that even after 30 years of internet introduced to our life, layman's life, India is still have 52% people have not, accessed internet. And I'm sure the technology that you people use is a microcosm of the user base, right? You all are very enthusiastic people who use ham radio and communicate on ham. Your codes are very scientific and robotic, and which doesn't, really gel with any of the normal audiences. Although the best part is that you deal with audio, which is the natural medium of communication of human beings, audio. And that is one of the biggest challenge also of internet, right? Which is very languages and scripted and all that, and requires too many gadgets, very expensive gadgets to communicate and so on and so forth. So I am here to share and basically seek help from all of you, because you come from many parts of the country, and you are also not from most of the people that I have looked at the profile, they're not from metros kind of thing, they all are in tier 2, tier 3 cities who are techies, and basically tinker with technology, and it's a hobby. And what Digital Empowerment Foundation imbibes and learned over a period of time, unless you make your hobby your profession, it's very little that you can do in life, to progress. You cannot learn education through educational process of four walls and schools and colleges and all that. You get into a hobby, right? So just a short little background that what DEF does is that DEF opens digital centers in villages, right? Those centers are computers, access to internet, broadband, and lots of various kind of gadgets. But they are supposed to be an ecosystem which is controlled and run and on an entrepreneurial basis by one of the villagers, right? These centers are actually to bring education through internet to the local people, because they are either out of school, they're not going to school, they can't afford school, or they're just not accessing the school, or health, because everything is now information based, right? You need Aadhaar card, or you need vaccination, or you need to fill a form. Everything is now getting online. So our purpose is that you open a digital center in villages and in remote areas and allow the local people to run on their own. Now in the last 5 years, we have started converting those spaces into a maker space. I don't know how many of you know maker space. How many people know maker space? So raise your hand. So actually those who are not raising, what you are doing is also makerspace, by the way. So makerspace is something that provides an opportunity to anybody to just try and do anything, without qualification, without certification, without even background knowledge, but just enthusiasm to do something. Like all the plumbers are makerspace people, all the cobblers are makerspace people. All the electricians are makerspace people. You guys are all makerspace people because you just get one little license, but then you start tinkering how to play with gigahertz and megahertz and so on and so forth to talk to people who do not, you will never be able to see also, right? So I am here to share with you that how do we do makerspace without commercialization or without making it consumer oriented. For example, Raghav, can you come up? Aap aoge upar? For example, look at this guy who is Raghav from Vaishali. Have you heard of Vaishali? No? So Vaishali is the place which is famous. It's a famous tourist place for Buddhists, for stupa. It is in Bihar, and that's the reason many of you haven't heard of it, which was the capital of the country once upon a time, no more now. So Raghav has developed this transmitter, which is 50 watt transmitter. And this is not developed now, it's about 20 years back. And he was almost on the verge of being arrested for developing this and using it for doing a community radio in his village in Vaishali. He was broadcasting on FM, proper broadcasting, without license. You know, you can't run you need a FM license to run either as a community radio or as a, all India radio license or something like that. He developed this and broadcasting, he got famous, and then as he became famous, he had to close it down. And I'm just saying that, so I got to know Raghav, इससे मैं मिला, हिंदी सब समझते हैं? हाँ, तो इनसे मैं मिला और फिर उसके बाद इनके साथ मिलके हमने डिजिटल सेंटर बनाया, फिर इन्होंने अब स्कूल भी चलाना शुरू किया है. So what he was making himself, and he is not even literate, educated from the perspective, he still don't know how to read and write. फिर अब ये पूरा कंप्यूटर सेंटर चलाते हैं और अपने गांव में पढ़ाते लिखाते हैं इनकी बीवी के साथ मिलके. एंड ही वाज, कब तुम 21 साल के थे या 20 साल के थे जब मिला था मैं? तो नहीं, और कितने साल के तुम थे जब बना?
17 साल.
हाँ, ये 17 साल के थे जब मैं इनसे मिला था, जब इन्होंने ये बनाया था. और ये बांस के पेड़ में लगा के रखा था और ब्रॉडकास्ट करता था अराउंड 30-40 कितना 30-40 किलोमीटर,
30-35 किलोमीटर के आसपास.
और इनके पास रेडियो की एक दुकान थी, उसमें गाना बजाते थे. ये सारे पायरेटेड गाने बजाते थे और पूरी दुनिया सुनती थी, मोस्टली भोजपुरी गाने सुनती थी. तो वो हमारे लिए एक्साइटमेंट ये हुआ कि क्या हम उस जगह को ऐसा बना सकते हैं कि हर लोग बनाएं इस तरह की चीज, हर लोग एक्सपेरिमेंट करें. तो उसके बाद से अब इनके गांव में ये पूरा सेंटर चलाते हैं.
अभी बिहार में जो है गांव के लोकल कलाकार जो होते हैं उनका ऑडियो वीडियो बनाकर यूट्यूब पर डालना, ऑडियो एडिट करना, वीडियो एडिट करना, उनका ये खुद से रेडियो असेंबल करना, डिजाइन बनाना, ये लकड़ी का बक्सा बनाना, वे गांव में जो है बच्चे लोग को ट्रेनिंग भी देते रहते हैं बीच बीच में.
ये रेडियो भी लकड़ी का इन्होंने बनाया, जो कि आप चाहें तो यहाँ से खरीद.
మంచి మంచి సాంగ్స్ వింటూ ఎంజాయ్ చేస్తున్నాం. సండే మార్నింగ్ షో విత్ మీ ఆర్జే రంజిత్, ఓన్లీ ఆన్ వివిధ భారతి ఆకాశవాణి తెలుగు, తరతరాల తరగని ఆనందం, అలరించే సంపూర్ణ.
और तो ये जब बनाया था पहली बार तो उस वक्त यूएसबी वगैरह पॉपुलर नहीं थे, तो अब इन्होंने बनाया तो इसमें यूएसबी वगैरह सब डाल दिया है, ब्लूटूथ भी डाल दिया है, ताकि आप मॉडर्न के तरीके से भी आप ये कर सकें. तो ये जो है, सो ही इवन दो ही इज इलिटरेट एंड अनएजुकेटेड, फॉर अस ही इज अ गुरु ऑफ मेकर स्पेस. ये बाकी जगह जाके ट्रेन करते हैं, सिखाते हैं कि कैसे हर चीज़ को खरीदना ज़रूरी नहीं है, आप खुद से बना सकते हैं, एंड सो ऑन एंड सो फोर्थ. तो इस तरह से एक और एग्जाम्पल है, जैसे आई डोंट नो आप लोगों ने देखा होगा कि नहीं, ये VR बॉक्स है, वर्चुअल रियलिटी बॉक्स. लोगों ने, बहुत सारे लोगों ने वेबसाइट पे गूगल का देखा होगा, लेकिन ये हमारे पौंडीचेरी में एक मेकर स्पेस है, वहाँ के बच्चों ने बनाया है. और वो हर महीने 200-400-500 बनाते हैं और बेचते हैं. और ये सिर्फ 150 या 200 रुपए लगते हैं बनाने में. और इसमें झूठ बोला मैंने, कितने में लगते हैं? हाँ, 450 लगते हैं. वहां तो उन्होंने बोला मुझे 200 लगते हैं. एनीवे, तो ये खुद असेंबल करते हैं बच्चे, खुद ही कार्डबोर्ड लेके बनाते हैं. इस पे जो स्क्रीन प्रिंटिंग खुद ही करते हैं, ये सब मेक टू वगैरह. और लेकिन इसका इस्तेमाल जो है सिर्फ बनाना नहीं है. अब इसमें मोबाइल लगा के फिर उन्होंने एक ये भी किया है, वो कहाँ है किताब, उन्होंने एक पूरी वर्चुअल रियलिटी की QR कोडेड बुक बनाई है. अब ये QR कोडेड बुक का मतलब ये है कि आप इसमें जितने भी वर्चुअल रियलिटी से रिलेटेड यूट्यूब पे वीडियोस पड़े हुए हैं, उसको ढूंढ के बायोलॉजी कहाँ से सीखें, फिजिक्स कहाँ से सीखें, उसका क्या सीखें, उसके लिंक को QR कोड करके उन्होंने पूरा एक डायरेक्टरी बना दिया है. तो इससे क्या है कि आप बहुत सस्ते में फिर आप लर्निंग का प्रोसेस चल सकता है. तो ये वहाँ पर पड़ा रहता है और मतलब लोग सीखते भी हैं तो बनाते भी हैं. और हम एक मेकर स्पेस से दूसरे पे अगर जाते हैं तो हम ये नहीं बोलते कि आप ये खरीद लो. You see one, but you start making something like, you might be saying that kya Bitex, right? You don't only buy from Farhan, but you start making yourself, something like that, Similarly, ये अगर आप लोगों को फुर्सत मिलेगी तो यहाँ आके देखेंगे, ये तो हम नहीं बनाते, लेकिन हमारे बहुत सारे गांव में इंटरनेट नहीं है, बहुत सारे गांव में इंटरनेट नहीं है. आपको भी पता है कि बहुत सारी जगह नहीं है, बट वी बिल्ड आवर ओन इंटरनेट. और ये हमारे बच्चे खुद गांव के खुद एंटेना बनाते हैं, उस पे टावर पे चढ़ते हैं, इसको उस पे जाके लगाते हैं, फिर वो सीखते हैं कि मॉडेम से कैसे ये बात करेगा, जियो लोकेशन सीखते हैं, और वो करके फिर वो इंटरनेट बनाते हैं. उसको हम बोलते हैं कम्युनिटी नेटवर्क्स. सो जैसे ये मान लीजिए कि यहाँ पे एयरटेल आ रहा है, दिस इज एयरटेल, राइट? फ्रॉम हियर वी विल बाय द इंटरनेट, then we will broadcast line with the line of sight to the village, whether it's 50 kilometer, 4 kilometers or whatever number kilometers, with many hops using 2.5 gigahertz and 5.8 gigahertz, which is allowed, 2.4 and 5.8 gigahertz, which is unlicensed spectrum. हम उसको यूज करके फिर एक बार गांव में जब पहुंच गया तो हम लोकल वहां डिस्ट्रीब्यूट करके खुद कर लेते हैं, हॉटस्पॉट्स बना के. और ये सब गांव के ही, मतलब ये मेकर स्पेस के लोग और ये लोग खुद बना के करते हैं. Did say anything? और फिर उसके बाद इसी, so this keep on continuing like this process, we keep on continuing. यहाँ पर जितने बॉक्सेस रखे हैं, ये बॉक्सेस भी बच्चों ने ही मिलके बनाए हैं, और या इनके ट्रेनर्स ने मिलके बनाए हैं कि इंटरनेट कैसे सीखें. जैसे सारे आजकल ऐप जो हैं वो सिंबल बेस्ड हैं, राइट? यू डोंट नीड टू बी लिटरेट टू नो देम. So it's a box for literacy and education which you can play. अगर मान लीजिए कि आप जैसे जैसे yeah, so let's say we are safety security is very important in internet, right? So there is a snake and ladder game for learning safety and security. मतलब ये कि अगर आपने पासवर्ड सेव नहीं किया तो सांप काट लेगा, आप नीचे गिर जाओगे, समथिंग लाइक दैट, सो देयरफॉर सो ये गेमिफिकेशन ऑफ लर्निंग, ये सब ये खुद करते हैं. एंड देन कीप ऑन मेकिंग, मे बी वी मे हैव मेड 4 games, but then they will start making another many games. There is one tool which is 3D printer, right? So when you have a 3D printer, you learn designing software, you learn modeling software, how to model things. So you also start learning software without knowing, programming or something. तो ये सारी चीजें ये बच्चों ने खुद बनाई है, जो बच्चे यहाँ बैठे हुए हैं. इन्होंने 3D में खुद ही मॉडल करते हैं और बनाते हैं, प्रिंट निकालते हैं. दे आर ऑल्सो लर्निंग हाउ टू डू ऐसी चीजें बनाएं जो हम बेच भी सकें. तो देन यू कैन ऑल्सो डेवलप एन एंटरप्रेन्योरशिप. तो वो सब भी करते हैं. सो वी आर ऑफ कोर्स वेरी इंस्पायर्ड बाय व्हाट इज हैपनिंग हियर. तो यहाँ पर हमारे आने का मकसद ये था कि हम अपने मेकर स्पेस में और लोगों को कैसे इंस्पायर करें. फॉर एग्जाम्पल, फरहान जस्ट टोल्ड के वी आर ब्रॉडकास्टिंग थ्रू सैटेलाइट, वी डोंट नीड इंटरनेट, राइट, on 8 Mbps video broadcasting. So maybe we can have this also installed in one of the maker space, and we can also start learning how to broadcast and all that. The idea is that when internet is going like a consumerism to the people should take education and learning into their hands to use maker space methodology to have scientific temper, to learn on their own, to learn what they want to learn rather than learn something that somebody else wants me to learn. So this is maker space is being institutionalized in that way. We have already opened around 50 maker space. We have 2,000 locations where we are present. Our idea is to convert all of them into a maker space so that people do their own thing, learn their own thing, make their own thing, and take everything into their hand. It's community driven and all that. That's basically I wanted to share all of you. I will be really, really happy if all of you, the LARC, enthusiast, to reach out to this community who is new to your ecosystem and give them some, understanding of what you are doing. We would like to reach to your place, and if you think that there are villages around you who are unconnected and unreached and all that, we would like to open a maker space in your area. And then you can become an inspiration, local inspiration to, do good to your village areas and all that. Because we are one of the youngest country in the world, with young population country. But somehow we are not getting a scientific temper-based education opening. And makerspace is one of the methodology that we are thinking is that it's a kabar se jugaad, you can literally, like this flea shop is actually the best asset for makerspace. We can buy all those things and make best out of it. We can create hundreds of things like that. And on the more commercial side, we have several antennas unused lying there. Anybody want to take, you can take from there. Since we are doing internet all the time, if you know any village which is unconnected and they can't afford to have internet, you will tell us, we will go and do the connectivity. We will train the local people, they will build the connectivity, they will own the connectivity, and they will run the connectivity also. So that's all. I hope I haven't taken too much of time. If there are more, do you want to learn that how these things are done and how these things are done? Basically, we take anywhere around 1 lakh or 1.5 lakh to create one ecosystem of makerspace. But it can happen because we also have a huge lineup of used computers assembly line, so we also bring it, like in Pondicherry we have a warehouse where we do refurbishing, we do recycling and all that, and made everything workable. So we set up those kind of things on a very low cost and then build upon them from there. Thank you very much.
Thank you, Osama, for this wonderful presentation. Let's give a big round of applause. Thank you so much. I hope a lot of us are inspired for this maker space. We all are a part of the maker space. So I call upon the next speaker, Mr. Radhakrishnan. Please come on stage. Thank you. All right, thank you so much. രണ്ട് മിനിറ്റ് കഴിഞ്ഞിട്ട് അത് എടുക്കട്ടെ ഒരു സാധനം അവിടെ പോയി സെറ്റപ്പ് ചെയ്തു.
from good morning everyone. I'm Radha Krishnan here, VU2 EHR. So I'll take you through a small session on something related to home brewing. How many of us in this group build their own circuits or do we? Yeah, so we do have quite a lot. And for the newcomers, building circuits and things for our own use at home is known as home brewing in our ham lingo. So with that I'll start. So during the last LARC meet, I had given a presentation on the basics of using KiCad, KiCad, whichever way you want to call it. So capturing schematics, then laying out a board, then generating production files. So in continuation to that, so we'll just get into the next level, or I'd rather say something which we could do along with using KiCad. Yeah, seeing this picture, don't worry, I'm not going to take you through some cooking session. Anyway, that's way beyond my current skill sets. So Spice is basically, it's a very fantastic technology and a software which has been used to implement that technology. It's basically called a simulation program with integrated circuit emphasis. So what it does is it allows you to model circuits before you build them. While you are designing them or before building them, it will allow you to model those circuits. So it's a general purpose thing, technology and circuit. It's open source. And then it's a simulator for analog circuits. When I say analog, now new tools are available for digital simulation also, but we, being from the radio side, we'll concentrate on the analog side of things. So it was developed by Lawrence Nagel in the University of California, Berkeley. He was the implementer, but most of the ideas and the advice came from his professor, Donald, who actually was his advisor for his PhD. So we have different flavors of Spice, if I may use that word. So there are the source code for the original Spice program was available at a minimal cost. Actually, they used to charge the cost of the tape or whatever media was prevalent those days. You could give that money and then you could get the source code. And many people have taken the source code and they have modified it and had come up with a lot of commercial as well as free versions. Sorry for that. Yeah, free versions. And one of them is LT Spice. So this was developed originally by Linear Technology and then later which became part of analog devices. It came out in 1998. This is again freeware and it comes with a huge collection of libraries. So when I say it is freeware, there are no limitations on the usage of this LT Spice program. There is no limitation on the number of nodes you can use, the number of symbols you can place on a schematic. There is absolutely no limitation on anything. And apart from the huge collection of component libraries and models which come with this LT Spice default installation, you have a huge collection of libraries available, contributed by users all around the world. So the first thing is obviously to get the software. You can head over to analog.com and then I have given the two links here. The first link will take you to the different simulation tools available from analog. The second one directly allows you to download the Windows installer. As far as I know, the LT Spice is available for Windows and Mac. So I unfortunately don't use Linux for my morning QTH, and then I really don't know whether it is available. But yeah. Yeah, Wine. Yeah, he says it runs on Wine, but there are definitely other spice tools available for the Linux platform. Most of them are command line based, but then you do have the graphic shells available for that also. So once you download this thing, for Windows, installation is very simple. Just double click. If you want to change the installation path, just change that and then accept the license agreement. That's it, and you are done with the installation. So now we'll just, I want to do it more of a hands-on session. So I'll just start the program, and then we'll just get through, go through the menu, how to do the schematics, things like that. So I'll just get out of this screen now. So this is the startup home screen for this program. So as any other Windows program, you have menu items on top, and then you have quick access buttons here. So this arrow key is the shortcut for starting a new schematic. So let me start a new schematic. And then here, if you look at it, once I have a schematic edit window in place, you have a lot of quick access buttons becoming available there. So one of the things you may want to look at is the control panel. And here you can set up many of these default settings, all those stuff you can set. And another thing which you may want to work on is the color palette, because I don't know how many of you are very comfortable with a gray background when you're drawing a thing. So you can select the item what you need to change here, say background, and then you can slide these things all around, and then you can change it to whatever color you feel good, you can use that. And here we have, these are all, this is the control panel what I showed you. This, what we call the running man. This is your friend. This is what we use for simulating the circuits once we put them on the editor. Is you have the zoom controls, then you have the tiling, cascading, window settings, the cut, copy. If you copy it, then you have the paste, then find, printer settings. Okay, these are the tools what we'll be using for capturing the schematic. So here you have the wire connector. This tool we use to connect components. Then one thing with any of this SPICE program is that any SPICE program compulsorily needs a earth thing. So without an earth it won't work, so you have to give an earth. This you have a label for naming a net. Then the commonly used components, resistor, capacitor, inductor, diode. And then here you have a huge selection of components. Then you have, this is the component selection what you have. You have most of the generally used components are available here. Then we have a move and a drag thing. Okay, so the most basic thing what I'll just show you an example. It's the finding the DC operating points of a circuit. So what we'll do is we'll select this component thing. So we will, let us put a voltage source here. So I just selected that voltage thing. I keep it here. And then I can put any number of, so for example, if you are laying out a schematic and then you have maybe 8, 9, 10 resistors, you select one and then you can keep as many, you left click, you can get as many components what you want, right click, you get rid of that. Now let us remove all the unnecessary stuff. Okay, so now we have a voltage source in place. Now for this DC operating point, let us make a small voltage divider. For example, let us say that you have a radio which is driven by a battery 13.8 volt, and then you want to add our Arduino to it. So you need to power a Arduino board. Yeah, so something like 9 volt would be sufficient for that. So now we have the basic voltage divider in place. Let us connect it up. So for connecting up, first I selected that tool, and then I just with the left mouse button. So one way to do the connection is each point, yeah, one by one I can connect it. And okay, so now I come here and I connect it. Another way is you select the start point, draw the line to all the different connection points, and then it will connect automatically. So that is another thing. So now we have this in place, and then let me connect the earth. Yeah, so now we are more or less done with the voltage divider. Now let us give some values to this. So here, since we are using a battery powered equipment, let me put it as 13.8 volt DC here. And then, okay, so we need an output also, right? So what we can do is we'll just put a label here. We'll call it voltage out, and the output type, it's an output. I'll select that, and then I'll keep it here. Then I'll connect it using a wire. It's as simple as that. Done. So now we need, from 13.8 volt, we need around 9 volts. So I've already calculated, you know the formula, that's R2 divided by R1 plus R2. So the first resistor, it's very easy to change the values. You just bring the cursor on top of the component, right click, and then you will get the place where you can enter the thing. So for this example, let me put 62 ohms or 62K for the top one. And for R2, I'll select 120, because we are roughly, with 13.8, we are roughly bringing it to 1/3 of that. So the same thing. Anyway, so now we are done with our schematic. So now how does LT Spice know what it is supposed to do with that? So for that we have something called the simulation command. What exactly do we need to simulate? So here if you look at it, we have transient, AC analysis, DC sweep, a lot of things are there. For the first start example, let us just get into the DC operating point thing. So by itself, if you notice, it has already put a .op. So most of the SPICE commands are dot commands. So .op means that you need to calculate the DC operating point. There are many other things what we can do. For the time being, a simple example. So we have done here. Okay. Now let us go and click on that running man. So once I click on that running man, you see you get a window where I'll just move it to a side. So the first network, the input thing, we have defined it as 13.8 volt, and the out, V out, that the thing after the divider, it is showing 9.0989. And then if you notice, it's also showing the current flowing through each of these components. Since it's a closed thing, yeah, the same current will flow. You can see that the source thing, it is shown as negative, because as you know, as the current flows like this and the direction is different, that is why you get a negative sign there. So I think you agree that it's a very simple thing, right, to do it. So just imagine you got a schematic somewhere, and then earlier days, I don't know, people, if you remember, earlier days when we had the circuits published in magazines and all, we used to have at every junction, the author used to mark the DC voltages there. So which used to be very useful, but then now, I don't know, it is not there, and then we take a circuit, we build it, and it doesn't work. We have absolutely no clue unless we go back, get into algebra or calculus, and then really seriously calculate each node voltage or current. We'll have absolutely no clue what is wrong with that. So just recreate, capture the circuit here, run a DC operating point analysis. Before building the circuit, you have exactly what should happen at each point in the thing. You have that thing. Okay, so now so the first thing was the operating point analysis. Now we'll go to something called the transient analysis. So for that we'll just, I'll just close this thing. I'll close this, not required. I'll go to a new thing. So here we'll just do a half-wave rectifier. So here again the process is the same. You go to the thing, you select a voltage. So here this voltage, since we are simulating a half-wave rectifier, we will be using a AC voltage here. I'll come back to that. So that's done. Then we'll put a diode here. Okay, so for rotating, once it is selected, you can just plus Control R, it will rotate, or you can go to the top menu and then rotation thing you can do. So I'll put a diode here. Then we will have a load resistor here. And like I said earlier, we need to have a ground for any of these things. Okay, and then of course we need a output also. So this also we'll call it as whatever out, V out. Output type is this type basically to yeah, that I'll come to that later. Okay, fine. So now again click on the thing where you connect the wires. You connect all these things up. So here we have connected it. Now we'll. So it's pretty simple actually. You can connect that, then here, then here. Okay. Yeah. So now we have this in place. So like I said earlier, since it's a half-way rectifier, we need to assign a AC source here. So I'll just go to the advanced thing, and since it's a thing, we will select a sine wave. Okay. And then we will see offset, we don't need any offset here. Let us say it's 5 volt AC. Okay, we'll select 5 volts here. And then we can select the frequency. So here I would, for ease of thing, I'll just put it as 1 kilohertz. Okay, why I have selected 1 kilohertz here is, see, when the frequency is 1 kilohertz, the period does 1 millisecond. So if I select 3 milliseconds, at least we can see 3 full periods there. So earlier we had a textual output, now we'll slowly get into the graphical output. So just selected the amplitude and then the frequency. So we have this in place. Now we'll go back and select a diode. So okay, so now I right click, it brings up this screen. Here I can pick my device. Let us, okay, now let us select this 11448. It's readily available. So I've kept there. The load, let us just put a 1K load. Okay, so now this is done. Again, now we need to tell this program what exactly we need it to do when you run the simulation. So we'll just go to the simulation. This time we'll select the transient simulation. So we just will give one thing, only one parameter. We will select, say, 3 milliseconds. The reason for 3 milliseconds is that we can at least see some thing because the source is at 1 kilohertz. So done, then we run the simulation here. Okay, now when I am in the simulation mode, you can watch the screen. When I move the mouse cursor, it changes shape into a probe. So we have different probes here. What you see right now is a voltage probe. If you want to measure the current, you bring it on top of the component, you can see a megger symbol, which is the current probe. So first let us monitor the input waveform. So you see we have given 5 volt input, so you get the input waveform here. So this is a time domain waveform. On the left hand side y-axis you have the amplitude, and on the x-axis you have the time. So now if I take the probe to the output, you can see that, can you see that blue lines there? Okay, what we'll do is I'll just put it on another, I'll make another plot plane and then I'll move it up. So now it is clear, right? So this is exactly what we expect from a half wave rectifier. We give a sine wave and then we get the positive pulses, we get it there. So now, let me just cut this thing off. Okay. So now on this graph itself, if we plot that thing, if you notice, there is a small gap between the green line and the blue line. The input and the output, there is a small difference. But on the left-hand side, if you look at it, the scale is too big. We really don't understand what it is all about. So what we'll do is so this is another beauty of this thing. Here, you can apply formulas to the graph itself. So what I'll do is I'll do this thing, I'll run the simulation, I'll do this thing. Okay, so now we had that blue thing which was slightly smaller, but we don't know how much was the difference. So here what I can do is, we know that we need to find the difference. So directly I can give a formula here. So subtract the output. So we have called it V out, right? So V out. Okay. So now if you do that thing, you can see that there is a 0.6 volt difference. That was the difference between the input and the output. Can anybody tell me why that 0.6 volt output reduction is there? Yeah, the forward voltage drop of the diode. So that's an expected thing, right? So that's why that difference was there. So we'll, I won't save it, then I'll go to the next one. So here we have, yeah. So now we'll do this more, we are getting closer and closer to our practical needs. Now we'll just put a very small low pass filter and then we'll do a frequency plot on that. Then we'll see how we can change things around and let's do it. Okay, so I'll again go back to the UI there. Yeah, so we'll start a new plot. Again, we need a source. So let us get back to this thing. Okay, now I'll not take time. I have already made all this stuff. So let us go and take that. It's AC analysis is here. Okay. So this is the thing. So I'll explain what is the voltage thing. You know it. We have selected an AC volt with 1 volt amplitude. We have a 1K resistor and okay, this let us change it to some, let us say, let's put 1 microfarad. We'll come back to that. And then, okay, this line here, this if you look at it, we have selected the dot AC, which basically means that we are selecting the AC analysis part of it. The DEC means that we are doing a decade sweep. And number of points per decade 100, start frequency is 1 and the stop frequency is 1 megahertz. So basically we are sending a 1 megahertz, 1 hertz to 1 megahertz sweep over this low pass filter, and then let us see what we get. So let us run the thing and then let us run the output. Oh, this doesn't look like a usable low pass filter, right? So what we'll do is we'll just close this thing, we'll go back and then let us change the value of this capacitor. We can go and put some 10 nanofarad there, and then we'll run the simulation again. Let me close this. Let me close this a little bit. So we'll run the simulation again so that half the screen is available. Yeah. Now let us see what we are getting here. See, now it's more like a proper low pass filter, right? So here, yeah, it is a low pass filter. Now we need to know at what frequency things start working. For that, you can just bring the thing here and then this click here and this will come up. So now you see it has already put a small cursor here. Okay, I'll move it, and then if you keep watching the magnitude part of it, it is slow coming down. Then the thing. So somewhere at, so let us see the 3 dB point. That's what thing might face, and then. So now the magnitude part of it, you can see it is 1, 2, 2.7, 2.9, 4, yeah, somewhere 3 point something. Okay, so at that place, you know, so I with this mouse and this, without a pad, I'm not able to control it properly. So at the minus 3 dB point, it is something like, it should be around 16 kilohertz, the thing. Okay, so this is how you can understand what is the cutoff point, and then when you are designing a filter, you can change your values, run the simulation without physically changing components or winding new coils. You can do all this stuff. So this is how you do it. Then I will save it. So I'll just take a little bit more time, and then, okay. So now we have touched the AC analysis. Okay. So now this is something we'll simulate a Hartley oscillator. Okay. So again, I'll not take much of your time. What I'll do is I'll use the one which I have already created and kept for our presentation here. So I'll just go to the Hartley oscillator, open that. Okay, so here one interesting thing what I wanted to show you is that, see, there's a very peculiar way in which transformers are constructed in LT-SPICE. Okay, so what you do is if you see here, we have 3 coils, and all of them are, the L1 and L2 are part of the oscillator circuit, and L3 is the tap through which we take the output. Okay, so we have L1, L2 and L3, and here you find this K1, L2, L3 and 1. So what this basically, how we create transformers in LT-SPICE is, you create coils. You can create, for example, 2 coils, and then you give a operator, you give it a SPICE directives. Now, it starts with K. Already I have used K1, so I'll put K2. And then I'll say that L5 and L6 are related. Okay, for that I'll put L5, then I'll put L6. And the next part is the mutual inductance. So if we have 100% linkage between these 2 coils, I'll put a 1 there. If the coils are at right angles with each other, I'll put a 0 there, or point not, whatever it is. Okay, so no mutual inductance is 0, and maximum 100% mutual inductance is 1. So I'll put a 1. So now if you see, if I keep it here, this basically means that the coil L5 and L6, initially they were 2 individual inductors. Now they will behave as a transformer. Okay, they have mutual inductance and the linkage is 100%. This is how you create transformers, or you can have your bipolar coils, tripolar, whatever coils you want, you can generate here. This is how you do it. Okay, so now we have this standard circuit, and then let us run the simulation here. Okay, so it has produced the thing. So now let us, it's too crowded here, let me just zoom in a part of it. Okay, so we have a thing here. So now here the experienced people will know, but for the newcomers, so what does this graph do? This again, it's a time domain graph. Here what happens is, on the y-axis we have the amplitude of the signal, and then if you look at it, the time also, you have the amplitude and then you have the time here. That is how this graph is constructed. Okay, so just imagine I have I need to display multiple graphs like this, okay? So in this plane, okay, in this plane, I display a 1 megahertz wave. So how will it be at this plane? The wave will go like this, so time will be progressing to that. Now let us say I want to display a 5 megahertz wave. So since this plane represents 1, the 5 megahertz plane will be somewhere here. Here the waves will go and the time will progress like that. If I want a 10 megahertz wave, it will be in front, right? Okay. Now just imagine you are viewing this from that side. If I turn the whole stuff towards you, what will you see? You will see here I have 1 megahertz, 5 megahertz, 10 megahertz. When I turn the whole thing towards you, you will see 1 megahertz there, you will see 5 megahertz here, and you will see 10 megahertz. That is viewing it in the frequency domain. So all of you who are using these SDRs, the waterfall and then the thing above, the FFT display is actually the frequency domain graph what you see. So here also, you can actually, it's very easy to view the FFT graph. So I'll select the V out itself here. So now look at this. So this was the largest wave here. This is what we had designed the oscillator for. Okay, so that if you look at the bottom part of the image, you can see that's around 4.127 megahertz. That's what we had designed it for. But then if you look, you can see so many spurs on that, right? At every the harmonic, you get spurs. And then, as you know, it is not legally allowed to operate. I can't put this thing on the air. Okay, so after this oscillator, from the output, if you put a low-pass filter, and then we can say that beyond this point, attenuate everything, and then you get a decent oscillator, which has a 4 megahertz thing. And here also you can see, since it is a this Hartley oscillator only changing one component, you can play around with changing the value, and then let us, it was at 4 point thing, let me change it to, increase it to 100 PF, and then let me rerun the thing. And then if I look at the fast Fourier transform, you will see that it has shifted. Earlier it was 4 megahertz, now it is something like 1.5 megahertz or something, and still the spurs are there. So it's actually without winding a single coil, without getting any component, without soldering, you have a fairly good idea how your design will work in real life. And this is how it works. So I'll close this thing. Okay. So I think I've just touched the very, very basic fundamentals of the whole concept of SPICE simulation. And then it's easy actually. It's nothing. You just download the program, play around with it. The magic smoke is not going to come out of your component. Nothing is there. You won't get electric. You don't have to fear about anything. Just start doing it. Just take microbit-X thing. You have the bidirectional amplifier there. Just to make the schematic of it, you have input on both directions. You feed a couple of megahertz waves. See how it works. And then that's how you get to, and once you are comfortable that your design is good, then you can get into the breadboarding stage or whatever it is. So these are the resources what I can suggest. One is the developer of the program, it's or the current owner, Analog Devices, that website. Then we have, in Groups.io, we have a group called LT Spice, where a lot of thousands of members are there. And then if you ever get stuck, you can post your queries there. And of course, in YouTube, yeah, but then be careful because there are a lot of, I will not call myself naughty, but then I do tend to post sort of things which really doesn't work, okay, or things just to make mischief. So there are other people also like that. So be a little bit careful on learning things there. But yeah, good videos are also available there. So any questions? Yes, sir. Yeah. Sir, can you?
He was asking some question here.
So in keeping with the use that we would have,
Yeah.
Are there toroids also available as a part of the library of
So
devices?
toroids are available, but I would suggest that you define the parameters of the inductor. So, for example, if you take T41 or some material and then if you wind 5 turns on that, you know how much inductance is there, right? And then that you can assign it to the inductor. And I just showed you the topmost level. If you really want, sir, I have 5 minutes? 2 minutes, okay. So there are many more parameters you can assign to each of these components. I just took that stuff. See, you have here you can, we just defined the inductance. The peak current, what you expect, you can do that. Series resistance is very important.
No, I'm not saying that.
Yeah.
So if I say use a T100 2,
Yeah.
right? It has its own parameters.
Inductors, you have cores. Cores are available, most probably from the manufacturer websites itself. Otherwise, you can look at that IO group, what I said, LT Spice. There you will get many component, the models are available there.
So if I say a T100.2 and I say
Yes.
I put in 10 turns of
Yes.
18 gauge wire,
Yes.
what will be the
10
inductance?
tons of 18 gauge wire, you will not be able to.
Okay.
So ready-made models are there. So wound down so and so, that you can use it.
But it's not variable, so
No,
I
that's
cannot
not-
play around with the
No.
inductor and the
There you have to go to the inductor properties and change that.
Okay.
Yeah. Sir, Vasan, sir.
So I'd like to add a point here actually. When you do spice modeling, few are available within the library. Few we can create by ourselves actually. Turns you likely to convert it into inductance, and the parameters what you likely to develop for a case of a toroid. There is a manual programming part. This is a schematic part. There is a back-end manual programming part. It's called dot model actually. You can build your own toroid for your specification actually. So you convert it as L1, L2. The amount of coupling involved and the type of spacing, whether it's oil or it's air or something or shell based, we could specify it and create your own model. So the inductor what you could use there could be your own model too. It can be modeled. So it could be used ready-made or you can build it by your own actually. I just want to add.
Yeah, that's correct. Yeah. Anything else? Yeah.
Radhakrishnan, the problem is we do not get the cores which the program would recommend.
See, it doesn't recommend any core, sir. You change the inductance of that, and then, for example, if you are using a toroidal core from Amidon, go to Amidon side. Amidon has a calculator. You select the core, you give the inductance, it will give you the number of turns what need to be used.
Okay.
Yeah.
Because we are having the limitation of the cores, and then to build an inductor to suit the circuitry which we are analyzing
First-
may be difficult.
I would approach it from a slightly different angle. I would first find out the inductance what is required for my circuit to operate in that thing.
And then bring that
Then go
core
back
to
and-
that.
yeah.
Okay, thank you.
Yes. Thank you.
Thank you, RK. Let's give RK a big round of applause. RK, here's your certificate. Thank you so much. Okay. There, that's. Thank you, thank you. We have the next presentation immediately. We have a Zoom meeting with Mark Prensky, I think hosted by Arpita, isn't? Osama, okay. Osama himself is doing the presentation. Please hand it over to them. Thank you.
So I just want to introduce Mark Prensky is the person who invented digital nomad. the word, the phrase, or digital netizens or something like there are several of these things. So Mark Prensky was supposed to be in India, but he didn't get visa on time. Otherwise, he would have been in person here. Mark, can you listen me? No. Hi, Mark. Good morning. Switch on. Yeah. How can Mark voice will come in the audience? Pin laga do. Just a second, Mark. Just a second. Lagao, lagao.
I love your hat.
Mark, can you speak up?
I see you moving kind of jerkily from one fixed place to another.
Okay, got it.
Okay, now it's a little better.
Okay, so I just introduced you to the audience here, just to let you know, the audience here is our...
Can you all hear me?
Yes.
I don't hear you at all, Osama.
Oh, it doesn't... Yeah, can you hear me now?
I hear nothing.
You don't hear me?
I heard the woman who was there before you, but I'm not hearing you.
Can you hear me now?
So something did properly.
Can you hear me now? No. Hello, can you hear me?
I still don't hear you if you were talking.
Hello.
But now I hear you.
Okay.
Now I hear you.
Okay,
Whoever that technical person is, he's great. Thank you.
And they are the people who are radio enthusiasts and tech enthusiasts, and I have introduced you to
Perfect.
them. So you can go ahead, you can take around 15 to 20 minutes, and then they will ask you a question. You can also tell them where you are and some of the things that has always inspired you. Go ahead.
Okay, well, thank you very much. And I'm Mark Prensky. Hi, everybody. I'm very happy to be with you today. I'm sorry I can't be there in person. That didn't work out for a whole set of reasons, but I hope to see you another time. And I can't really see you, so I don't know how many of you are there. But if you can make some noise or do something, I'll know who you are. Thank you. And I'm here with my good friend Osama Manzar, and that is, it's really a pleasure to be here. So I am in Palo Alto, California, walking distance from Stanford University in Palo Alto, and I am happily sitting in my home in my chair. That is a fake background behind me. But it's actually, we live in a pretty place and it's full of trees and things like that. And I have been to Hyderabad once in my life and I enjoyed being there. So I hope you are all enjoying that as well. And my background, as some of you may know, mostly I got into this business of talking when I invented the term digital natives and digital immigrants, and that was more than 20 years ago, and that took off around the world, and now people are still using that, and now we're starting to talk about AI natives, and we'll talk a little bit about that as we go on. So the topic that we have is the future of young people. And that's something that particularly interests me, because I think the future of young people is power. I don't know if you can see that. I hope you can. Can you see that? So nod your head if you can see it on the screen, the word power. But I think that power, this generation, your generation, will be the most empowered generation that has ever been seen in the world. And that's really a wonderful thing to be alive during that time. I'm very happy to be alive during that time, and I hope you are too. You're going to have the power because you have technology, and I hope lots of you do. And I just heard from Osama that you're here because you love technology. And what the technology does is it connects all of us. And what a miracle that I am here in California and joining your conference. And that, to me, is the best thing that I can do. I almost am happier to be here just because of that. What you also have, and this I was very happy to learn this relatively recently, is that you all 1.3 or 4 billion of you have digital identity now, which enables so many things like the passing of money back and forth, and is going to really improve over time. And it's something that India has that other places don't have. And you live now in the age of AI, of artificial intelligence, and that's going to change so much in our lives that it's really, again, a wonderful time to be alive. Now, the problem is that the power that we're talking about that you're going to have, it doesn't just come automatically. It doesn't show up in your lives. You're going to have to make yourself empowered. That's really your task. And we'll talk about how you do it and what that means. Because for me, I am empowered. To be able to say that means you have to be able to say, I can. Nobody can tell me I can't do this. I am capable of doing what I want to. I choose to do it, because this is not school where they tell you where to do. Empowered means you get to make your own choices of what interests you, of what concerns you, of what you're passionate about, and what you want to do. You also have to accomplish. You have to get things done in the world. And this is something, again, that not everybody does, and certainly is not always done in school. But that's what life is about, accomplishment. And why do we accomplish? Because we want to make a positive impact on the world. And that's what defines for me an accomplishment, is making a positive impact on the world. So if you can do those 4 things, I can, I choose, I accomplish, I make a positive impact on the world, and you do it over and over again, it becomes a spiral of empowerment, and you move up in the world as a more and more empowered person. And interestingly, the empowerment doesn't come from what other people put into you. A little bit, that can be helpful from at time to time, but it really comes from what comes out of you, from the accomplishments that you make in life. And those accomplishments and the impact that those accomplishments have is what defines you as a person and a unique person in the world. So you use this power. I think there are many, many ways to use it, but I look at 3 big areas where power can be applied. The first is to realize dreams that you have. And of course, everybody has dreams, but in the past, it was not always possible for young people to realize their dreams. Now it's becoming more and more possible. So I encourage you to have your dreams and try to realize them. You can also use your power to fix problems you see. And everybody sees problems. Every place has problems. And even youngest people see the problems. And everybody cares about different problems. Some people care about people. Some people care about the climate. Some people care about the environment. And so you have to pick what you care about and try to fix it. And the third category is helping others that you care about, because that's what we need to do so you can realize dreams, fix problems, or help others with this new power you have. And so I'm going to finish up with some recommendations. And there are really two big areas of recommendations. The first area is about projects. And projects are becoming a very important thing in the world of business, in the world of growing up, because it's the projects that we personally choose to do and that we accomplish that makes us the unique people that we are in the world. So you should do as many of them as you can. And what do you need to do a project? The first thing that you need is to just know yourself. And that's something we don't do a great job of in the world, helping you understand at any particular time and age what you care about, what you're passionate about, what you're good at, what you love to do. You need to understand that so that you can choose the projects that you want to do. Then you have to build a team, because you can't do most things by yourself anymore. You can do some, but mostly things happen in teams, often small teams. And so you need to build a team around the world. First, you can look at people who are close to you, and the conference that you're at is a great place for team building. But then you can reach out to the entire world to find people who are interested in the same things that you are and make virtual teams and get together virtually. What do the teams do? They help people. They help others. So the third thing that you have to do is find the group that you want to help with your project. And you have to do this in a way that really helps them. To do that, you have to get to know them. You have to understand. Some people call this empathy stage. You have to know what they need. And there's a great story that I heard just recently about a group that wanted to help a group of people. I guess they were possibly in the United States, and they wanted to help some people in Africa. And the women in this village had to walk long distances carrying big pails of water on their heads in order to bring water to the village. And the people doing the project said, "Oh, that's terrible. We can fix that." And so they went there and they built a well in the village, and it brought water into the village. And they thought they'd done a great job. And a year later, they came back to the village. And what did they see? They saw all the women in the village sitting around drunk, because they had nothing to do anymore since they didn't have to carry the water. So when you do a project, there are always going to be second-order effects and unanticipated consequences, and you have to be careful of those. So you want to design a solution that you think, in your best judgment, is going to have a positive impact on the group that you want to help, and whether it's a technology solution or any solution. And then the final step is you have to make that impact. You have to have what I call a measurable positive impact in the world. And how do you know that? You have to be able to point to something, and you have to be able to say, See that? Before, that was not very good, or it didn't even exist. And now, because of what my team did and what I did with my team, it's so much better, as you can see. So that's the metric for MPI, before and after. So I recommend you do lots of projects, as many as you can. And the second thing that I recommend is what I'm doing right now, which is learn about and using artificial intelligence. And some of us have it, some of us don't have it all yet. I certainly don't have it all. I've gotten some of it, but get it as quickly as you can. And even if you don't have it, learn as much about it as you can and think about it and think about how you would use it. When you get it, use it whenever you can. Use it every day. Ask it anything that you think might help, as if you had a friend or a colleague working with you. Use it for your projects. Use it for everything that you do. And here's what's most important, and where you really come into the picture: figure out new ways to use AI, because we are growing up with AI. It is an infant. It's just starting out in the world, and it's going to grow up with us. But we will grow up at a human pace, and the AI will grow up at an exponential pace. So we're going to have to work hard to keep up with it. And what I've been the recipient of, and what I really recommend, is that as you learn things, whatever it is that you learn, you share it with as many people as possible. So those are the things that I want to communicate to you, that you are really the most powerful group of people the world has ever known. But you're going to have to do some work to become as empowered as you're capable of having, as being. So now I'd love to answer your questions. This is my email. I'm going to offer you to write to me. Send me an email if you have a question, if there's something you'd like to know, if you think that I can be of help, please email me. And I look forward to talking with you. And now I'm going to stop my sharing and talk to you in person. I hope that was useful. And thank you very much for having me at this conference.
Thank you, Mark. Thank you. That was wonderful. Very short and crisp. And the best thing is that you are asking people to take responsibility of themselves, right? To do projects and do things. One quick question before anybody asks a question is that the way world is moving, we are always treating the world population as consumers. And when you treat people like a consumer, they also behave like consumer, which is irresponsible and without consciousness. And digital, consumerism or digital is creating this consumerism even more and more and more. So how hard it is to become a responsible citizen in a digital world where AI is supposed to solve all my problems?
You broke it up a little bit, but I think I understand the gist of your question, if you can hear me. It's interesting because we play both roles. Everybody needs to consume something, otherwise there was no point in creating it. But the wonderful thing about the times that we're in is that it's so much easier for anybody to create things. I just created this past week an AI that you can inquire about Mark Prensky, and I can have a dialogue with you. Now, I'm not a programmer. I couldn't do that. The images that you saw in my presentation were all made by AI, by ChatGPT. I don't have to be an artist. I'm not a very great artist, but now I can say to ChatGPT, paint me a picture of enthusiastic Indian young people who want to do this, make it photorealistic, and it did. So the ability to create is now in all of our hands. And there are people who talk about the creator economy because we are learning how to do this in ways that bring some income into us, among other things.
Great, thank you very much. Anybody
so please
has a question
participate in the creator
from the
economy.
audience? I saw that the photographs that you have used in your presentation was AI made. Usually Indians would love to see themselves so handsome and smart in those photographs. But yes, it was certainly AI generated.
My pleasure. Well, not my pleasure, AI's pleasure.
Any in the audience? Yeah? Yes? So there is a question there. Just hang on there.
We have in the audience diverse people like coming from different backgrounds. So we would like you to tell us a little bit about your work and yeah.
Well, I'm having a little trouble hearing that, so perhaps, Osama, you can repeat the question.
Yeah, it'll be, so because we have diverse crowd in the audience, we would like Mark to share about his work.
Okay, so the audience are from diverse places and community. And there is a question that can you also tell us that on a day-to-day basis, what do you do? And they want to feel more influenced by your work. I mean, what do you do on a daily basis? Having said that you invented the phrase called digital immigrants and digital natives, but you know, apart from inspiring people, what do you do?
Well, thank you, and I love that word diverse, and certainly the what I was hoping for when I was planning to come, and until the last minute I was coming, was to go around to see much more of India than I have seen before, and to understand the great diversity that you have in India. What I am most concerned about in my life, and what I am concerned about, is how can we give young people and help, not give them, but help them become as powerful as you are capable of now being. That's a huge change in the world, that young people are powerful. They weren't before. You used to, when you were young, you just had to do what you were told until you grew up, and then you could be powerful. But now you can do things that are really amazing in the world, and solve problems and realize dreams and help other people in ways. So I try to figure out how to help people do that. One way I do it is by writing, and I spend most of my time writing and talking to people, and I have 10 books that I've written, and so I'm interested in empowering them in the ways of first helping them with self-understanding. So the more you understand yourself early, the easier it will be. I was in my 30s before anybody ever said to me the words R&D, research and development. And when they said that, my eyes opened wide, because I never had heard that. And I said, that's what I do. That's the kind of thing I do. But I had to wait till I was 30 to hear those words. And I talked to a young woman who was suddenly in event planning. And she said, no, that was absolutely a revelation to me. And it wasn't until later in my life that I heard that. So we just don't do a good job of helping you understand who you are and then connecting you with particular areas or people or things that might help. And I think AI can play a big role in doing that. So I want to do that. I also want to use technology to empower people, because we have a lot of what's called EdTech in the world. And that's technology that tries to help the education world and tries to help you learn. But in my perspective, learning by itself is good, but it's not enough. We learn in order to accomplish. We learn in order to have impact. And so the next step should be terribly enabled by technology. And of course it is with our mobile phones. And since I know you're a radio gathering, I hope everybody knows that a mobile phone has, I don't know what the number is, it's at least 5, probably 10, I've even heard up to 20 different radios in that one mobile phone. There's a radio for Bluetooth, and there's a radio for Wi-Fi, and there's a radio for 4G, and there's a radio for 5G. So radios play a huge part in this, but other ways to empower people through technology exist, and businesses use some of them. I don't know how many of you know, some businesses, big businesses, develop software 24 hours a day around the globe. And the people in one time zone take out the software from the vault, work on it. At the end of their shift, they put it back in the vault. The next time zone takes over, takes the software out of the vault, works on it, puts it back. And that goes on 24 hours a day around the world. Now, that's not something that happens in school. That's not something that most young people do. And the biggest form of using technology as empowering, and I call it empotech, not edtech, but empotech, the biggest is AI, because AI empowers us so much by adding in to the answers it gives us all of human experience. The AI goes out into the web and it can consult everything. So if you say, well, I would like, 10 points of view on this, on whatever question you have, or I'd like to know how people have thought about this in different places, or I would like to know anything, or take the role of somebody who is an expert in this or in that, AI can do that. And that's why it's such a wonderful, powerful thing that I hope that all young people will get to start to work with as soon as possible. And I hope you're among them.
Thanks, Mark. We would end on that. People are clapping. I'm giving a title on the screen saying people are clapping like we do to disabled people in terms of what's happening. So we will end there because we need to get into the second session.
Thank you.
And we will get in touch with you on email. Yeah, so there is a presentation for you.
Mark, hello.
I appreciate that. Yes, sir.
Mark, my name is Thomas, and on behalf of, I represent the LARC, the Lamakaan Amateur Radio Club. And during this convention, that is for the annual radio convention, since you have been the speaker, we also have a certificate made out in your name. So
it's breaking up slightly, but I am very grateful.
Yeah.
Now I see it. Okay. Oh, I look forward to putting that on my wall.
Okay. So I will be handing it over to Osama, who on your behalf will accept it from us.
Mark, for you.
That's for you. Thank you so much.
Okay, well then put it close so it's in focus, and I'll take a screenshot here. It was in focus before, and now
it was in focus before, it seems.
Maybe you need to move back a little bit. I don't know. Almost. Okay. Okay, that's good. That's good. I think if you move back, that's perfect. There you go. That's perfect. Okay, I have it. And now let's see. Show me your face, Osama, so that we can take a picture of all of us. Perfect. Thank you so much. This was great. I'm so glad that it worked out that we could do this virtually. And I'm very appreciative, and I hope it was helpful. I look forward to getting everybody's questions, and if you have them, and you're always welcome to contact me. Thank you.
Thank you. Thank you. Let's give Mark a good round of applause. We have a next session. Mr. Vasant from CBIT, please come on stage. Sir, the stage is yours. Thank you. Sir, if you can come. But before he begins the session, there is a small announcement on SSTV by Ravi Teja. Please go ahead, Ravi.
So hello everybody, there'll be a treasure hunt event that will be happening just after the lunch. So it's going to be on SSTV images. So I hope everybody would participate in it. There's no registration fee or anything, but the prize money is huge. So do participate, try to enjoy, okay? For this particular event, you might need to download one particular app called Robot 36. It's available on Play Store, so please try to download it. It's Robot 36, R-O-B-O-T 36. Thank you guys. Over to you, sir.
It's noon actually. Maybe good afternoon all. On behalf of LARC, I just thank for this opportunity. Last year, myself and my team, we presented with a CANSAT what is being done with the help of Lamakaan. And this year, I'm going to talk about the antennas, what they could use it on a nano satellite actually. So on this regard, LARC has helped us directly and indirectly on building up of few antennas, both for the satellite and in the ground station actually. So that is what we'll see. But before looking on to that, right, what are the constraints you have in building up an antenna for a satellite which is of a smaller space actually. That's how we look in. So moving forward, a nano satellite is coined, not just it is not visible, it is scaled down version actually. The word nano, it doesn't mean every time it is not visible. From the existing size, it is scaled down to 10 times down, right? You call it as a nano actually. You tend to look into a bigger satellites called larger satellites. By then, the cost to lift from the ground and to put it into the orbit, it takes a lot of fuel. So agencies like ISRO, European Space Agencies and NASA, they have started launching these sort of small satellite, not small, nano, pico or femto satellites, multiple in a clusters or in the form of a constellation, so that the lift-off cost could be reduced and the chance of being successful is huge actually. So that's a basic idea. So a nano satellite, in commercial terms, it's called CubeSat basically. Any satellite or any commodity of dimension 10 centimeter above is given with TLE. Right, and the TLE is hosted in a website called NORAD that deals with the orbit it takes, the velocity in which it travels, and the speed at which it reaches your ground station and so on actually. So the dimension is 10 centimeter cross 10 centimeter cross 10 centimeter. It's a cuboid basically. So any object you likely to put into the orbit, it should be greater than 10 centimeter. Then you have you can track it from the ground. That's a basic idea. Now, this 10 centimeter cross 10 centimeter cross 10 centimeter, it's called 1U. So if you're likely to stack a cuboid just over it, it becomes 2U, and one more 3U and so on actually. Over the history, in the morning when Farhan presented a hockey stick diagram kind of a thing, I was being part of 2 of the satellite missions before. One, it's Satyabama University satellite called Satyabama Sat. Another one with Swayam University Sat made by College of Engineering Pune. Right, that was 1U satellite, something which looks like here, and 2U, I'll be showing you quite a way. In both the cases, we used antennas which cannot protrude out of this structure, because this structure will be placed onto a rocket and you take it to the LEO orbit and you try to eject it out to the space. You don't want any part of the antenna to protrude out like your hair so that it gets stuck. So your mission is totally collapsed actually. So in Swayam satellite, which is made by College of Engineering Pune, they had a buckle strip, a Velcro kind of antenna. And in our satellite, we had a burn wire mechanism antenna, wherein which antenna will be coiled with a non-memory based structure. And once it is burned, a hinge opens and the antenna comes out actually. So pretty difficult and a lot of engineering needs to be brought in for a successful launch. Why? Because after you launch a satellite, the communication between the satellite and the ground station is your antennas. If antennas are not deployed, the power what is required to communicate with the ground station does not establish, and thereby putting the entire mission under jeopardy. That's the main reason. So now on, we call this a nano satellite because of its scaled down version, and commercially it is called CubeSat. Yeah, as for now, as for my friends of Dubai space agencies and European space agencies, there is no interplanetary missions using these nanosites due to its power limitations. Because the problem is in space, when you try to put your satellite, you require power. You don't have enough solar panels around your satellite to generate those powers. So active devices such as thrusters and other altitude determination algorithms cannot run on these. So you should be careful. And the design of antenna and how do you place it onto your satellite also plays a very vital role. So on that regard, the satellites, what I'm going to talk now, it's all about the satellites which operates at LEO orbit from 300 to 700 kilometers, which are already launched actually. So any satellite launched, it is for a specific application. The applications are weather, natural disaster, pollution, water, measurements in space, are reflection of few parameters from Earth's albedo to the space. The data what you acquire when compared to the stations what we have here, right? The data are more pure and are more accurate. So that's the reason why you need to go for satellite technology rather than the conventional technology what we have here. So that's the main idea. So any applications you can choose. Now for the purpose of prototyping, we have taken a lot of techniques such as a transponder application, a beacon signal of health parameters of a particular what you call subsystems what is being built up. A lot of small applications have been built up and it is being tested. Yeah, this is how it looks like. The one, it's 1U, right? 1.5U, it's 10 centimeter cross 10 centimeter cross 15 centimeter. 2 cuboid of 1U is 2U. And 3U and 6U. 1U, lot of people have come out with 1U. Recently, Israel has launched 101 1U satellites with constellation mode. So what happens in 1 degree of plane, multiple satellites are launched. So for in a day, at least 14 times your satellite comes around your base station, right? Or your ground station basically. So what happens is like you'll have a continuous track record of signal being acquired from space and is being transmitted down in different planes at different orientations. So what happens, you have a periodic what you call data collection. So it eliminates the failure of the previous satellite missions with this constellation approach. That's the trend in satellite technology actually. So that's how it works. 1U, many have done it. 1.5U, they have not tried anywhere in India. Recently, 3.2 satellites called UnitySat were launched in association with ISRO from Chennai, from Karnataka, and from deep south of Tamil Nadu. Right, all this done. 2U, Satyabama satellite, it's 2U. And 3U, IIT Kanpur Juhnu satellite was, these are student-made, academic institution-made satellites launched from Indian Space Research Organization actually. 6U, currently they are building up, European space agencies and European builders are more interested in building these sort of things. I'll be showing you one umbrella-based what you call antenna for deep space communication actually. So To start with, there are different substations of a satellite. You have a payload. It could be a spectrometer, it could be a camera, or it could be just a chunk of information. What do you likely to store in your satellite? From there, you can bypass it on to your ground station as and when it comes over the field of view. The next comes the structure of the satellite. Predominantly, everybody feels to have a cuboid structure. That is called a 1U class structure, standardized by the universities like TU Delft from Netherlands and few more space which are pioneer in this field of nanosatellites actually. Finally, you need to have a power supply for the entire satellite to work on with. So you have a solar panel based lithium ion driven electronic power supply, followed by an onboard computer to to acquire all your information from your sensors, to packet it up, send it via your RF signal through the onboard communication, and to stabilize your satellite. I'm talking about 500 kilometers where you don't have the gravity. The satellite wobbles in the space. You need to detumble it, stabilize it, make it point towards Earth, acquire the information, and as and when you try to send it from the satellite to the ground actually. That's what basically happens. Here we are very much bothered on this onboard communication. Along with that, the antenna deployment mechanism, what is used inside the satellite actually. So, this is the normal launch sequence. The satellite is being launched in the PSLV. You have the satellite being placed in the top part. Rest of the part, first the dry fuel and then the liquid propulsion fuel actually. Once it reaches a specified altitude, your rocket, right, you try to deploy your satellite into the space through a deployer. Sir. So you try to deploy it in your space. It comes out of a pea pod. After it comes off the pea pod, based on the timer mechanism, you have the antennas being deployed. This is where it is very crucial to learn about the antennas, what is required or what is to be used for a satellite mission basically. So if this antenna is not deployed or it is only semi-deployed, then it is going to hamper the entire communication or the lifespan of your satellite assets altogether. Then you need to detumble it, make it point towards Earth, and when it comes over the ground station, you try to acquire the information or send or receive the acquired information from the space. Yeah. Antenna systems in nanosatellite, basically, there are quite a few number of factors which governs the antennas, what is being affecting the antenna design. First one is the material what we use actually, right? It could be a conductor, and off late, through the research, people have started using dielectric materials as an alternate for the conductor due to the heavy amount of electrical interference what you have in that altitude actually. So patch-based antennas are normally being used apart from the conductors being used. So the antenna material, the location where we are likely to put the antenna in the satellite actually. So you need to understand, normally we call any flight dynamics pitch, yaw and roll. We normally try to put it in any of these direction for the location. Next, there will be a deployer to push your satellite into a concerned orbit. So thereby you have a deployment mechanism. So you need to make sure that your antenna does not deploy, does not hamper your deployment mechanism, or the antenna kept in there should be careful. Next comes your antenna geometry. The measurement of the UHF or a VHF antenna or a patch-based antenna, what is kept on your the entire satellite. Then comes the data rate in which it is going to transfer. This is once again every parameter what we take is a power crunch parameter. If the data rate is more, then automatically the power consumed will be quite higher. So we have to bring in a trade-off such a way that it does not take more power, or it does not use as an optimate data rate to send the information from the satellite to the ground station actually. So planned antenna orientation, right? How should I make my dipole to point it towards the ground station? That also plays a vital role. So that is in turn being governed by your attitude determination and control system. Then the size of the antenna, what could be the optimum size which I could use to obtain a desired result. Then comes the financial amount involved in the design of the antenna. Right. The major requirement of an antenna put onto the space, right? One is the link budget. So link budget can be obtained using Frill's equation. It's a standard equation which we could use to obtain the link budget. Any values which is greater than 3 dB, I'll be able to acquire a good signal reception down in the ground station. And next comes the number of antenna elements you require. Normally in space, whatever they're likely to build and they're likely to send, they do it in two. Because even if one fails, another one would prove them to be handy. So redundant mechanism comes into play here. So we go for the number of antennas. Then antenna that suits a suitable polarization. So we know circularly polarized is really good in what you call for the antennas. So predominantly in satellite communication, we always use circularly polarized polarization for it actually. Yeah. Right, coming to the link budget involves the transmitting power from the satellite, the operating frequencies, then the gain in which it is to be operated, and the radiation capability. One more problem is that, right, the antenna, what is likely to radiate should not affect the other components of your satellite. That also plays a very vital role. If any of these parameters fails, the entire mission fails actually. That's the reason why antenna design and its usage in the satellite design plays a very vital role actually. Right. Requirements of an antenna in a nano satellite operating frequencies, predominantly they have been using UHF and VHF antennas. Main reason, it's because of its low cost and quarter wave wavelength antenna. I could bring in beacon, modems and transponder modes into this UHF and VHF antenna. Few satellites like Nurul Islam University satellite, they have used S-band antennas where after putting it into the metal box, it is prone to a lot of internal radiation or the signal emitted out of the system affects the system more. It operates at 2.4 gigahertz, offers a 10 dB gain with mainly used for a higher orbit than the LEO orbit actually. Coming to the K-band antennas, not many dare to use this. Possibly could be a lead to use K-band antennas. Predominantly used in radar applications. You need to have a better what you call antennas such as an umbrella-like reflector antenna with a higher gain. Yeah. Next comes the size and compactness. Smaller the antenna with better gain is always preferred. I'll show you some of the commercially off-shelf antennas offered by few companies around the world, wherein which these antennas have been miniaturized, made it into compact, and it is being sold all around the world actually. It could be a single boom, which I've told you, more of a Velcro kind of a structure, or it could be a quad boom getting deployed one after the other based on some command or some mechanism actually. Till 2017, there have been quite a large number of satellites. After 2017, there is a halt in the launch of satellites in India, predominantly. After COVID, they have launched only one satellite, student satellite, as part of Indian academic institution, which is called UnitySat. Right. So till 2017, I have made the comparison of different antennas which are used for the nanosatellite application with the communications frequency, with the required transmitting gain and required data rate. And this would vary based on this type of application. If it could be an earth and climatic observation, the application frequency is different, the communication, background communication is different, the transmitting gain is different, and the baud rate is totally different actually. So we need to make a trade-off between each of these specified frequency. Okay, materials. Now there is a problem once again, unlike the antennas what is built in ground, we could not build an antenna in the space actually. Why? Because it is prone to electrical interference. The antenna, once it is deployed, it should not be affected by any of the external means or the conditions out there. There you have a baking temperature of plus 60 degree, and the temperature goes, when the satellite goes behind the earth, the temperature goes less than 0 degree actually. So when the temperature goes less than 0 degree, all your charger will not charge. Right, less than 20 degree, your charges will not charge. You will have an issue charging. When you don't get power, right, then automatically it is waste to use an antenna. So a proper optimum material has to be used. Some Kapton polymer. There are few Kapton tapes made out of it. After we use conducting material, we tend to tape it around and we recoil it and keep it within the antenna. And it should have a non-memory structure. Once it is coiled, like folding, bending, it should not happen. So you have to choose a material such a way that it is of that sort actually. So, right, material boards like Rogers board could be used, an aluminum based material, mylar films or membranes could be used as a reflector. Right. These are the different types of nano-satellite antennas you have in. You have a patch antenna, monopole antenna, which is predominantly normally used as it is low cost, reflect array antenna. I'll be showing you two videos of one dipole antenna being deployed and one more being the reflector, this sort of umbrella based antenna being deployed out of your structure. These are the different antenna configurations. Those are the ones which are kept on the left hand side actually. For Ka band, we normally use these sort of umbrella based antennas. Yeah, these are the commercially viable antennas you have actually. Right, UHF antenna, all being deployed. S-band antenna, right, it's more of a patch antenna with high gain. All are ready-madely available. All that you need to do is like test it in a particular environment onto a particular thermo profile and putting into the environmental conditions of the rocket in which you likely to do, then assemble it in the part of a satellite, then launch it into space actually. That's how it happens. Individually also we can build it. We have had a try of that too as part of our DIY project also. Is X-band antenna, it's a patch antenna. Look at the size of the patch antenna. Multiple patch antennas can be kept on a single board. 2x2 patch. 4x4 patch. And comes your rain cube antenna. I'll play a video. This is for interplanetary mission. Right? So far, they have built, but nobody is affordable enough or daring enough to put it into the space as of for now. So this is the deployment mechanism of the antenna being used. We are currently trying this actually to have this sort of antenna and its deploying mechanism actually. Deployment mechanism. Yeah, I'll wind up in another 5 minutes actually. This is my baby. right? I was a project lead for this satellite called Satyabama Sat actually. Here the satellite has got two compartments. One compartment fully stacked with the basic component of the satellite. Another compartment with your 1U payload. And you have the antenna deployment mechanism coming up as part of the board which is kept on the top actually. So this was tried and this is how it looks like the satellite with stored mode and exploded mode. And this is how the board of UHF and VHF antenna looks like. This is the antenna what is being kept inside actually. It is being recoiled and will being kept inside and you have a door here and the door is controlled by means of a nylon or a dynamo wire and these are made to pass through the resistor. You have a suitable command given from the onboard computer after a particular time delay, right? The resistor gets heated up and this dynamo wire gets burnt and this door opens and this recoiled antenna, it's being deployed out actually. Once it is deployed, all the other activities takes place. So that's a burn wire mechanism, the blue color one. Dynamo wires is available online. Anywhere where pyros are not major constraints, you can use burn wire mechanism to deploy your antenna basically. And in the stored condition, if you're likely to test, right, we used BPSK as the modulation technique. The spectrum of the BPSK is being given here. So this is during the pre-deployment and after deployment. I'll show you the real time of the antennas being used. We used VHF and UHF antennas. This is the satellite actually, a 2U satellite. It works on the timer based. The ground station is mimicked there. And here, blue color one, what do you have? Yeah, you can find the antennas are being deployed after a particular time delay actually. So once it is done, it moves on, maneuvers from one stage to the next stage of its operation. Yeah, this is, I told you, if you could design your antennas in UHF and VHF mode, 3 different modes are already easily at no higher end cost, you could build it up. One is the beacon mode in which you can transfer your information. Even this was done as part of our, what you call, DIY project. Thereby, students are able to build their own Morse codes in transmitting signal lesser than 1 watt actually. Then telemetry mode. Then whatever we build on one side, the other side also has to be spoken. You need to have a ground station in the ground, good gain ground station, wherein by when the satellite goes over your head, right, you should be in a position to acquire signals from the satellite as easily as possible actually. So a ground station is also being built with VHF downlink antenna with 14 number of element cross Yagi, operates between 143 and 148 megahertz. And then UHF uplink antenna with 432, 440 megahertz. Once again, cross Yagi. This is the schematic of the antennas. This is the schematic of the ground station in Satyabama University, Chennai. In recent floods, it was demolished, and not this flood, 2018's flood, because of the cyclone, it is demolished. But there are a lot of ground stations available around the world to help us in tracking the satellite actually, in the form of hams and in the form of universities and academic institutes actually. So this is the gain. You have an SDR to track your satellite from the antenna and to use different softwares to find out when the satellite would come over your particular destination and at what time track it precisely. At 500 kilometer orbit, predominantly circular kind of an orbit, every day 14 times the satellite comes over our ground station, of which 9 in the morning and 5 in the night. So you could plan your mission accordingly. So you could do that tracking software, and with the help of A lot of open source tracking softwares are available. Also, you have SDRs, open source SDRs are also available. All that you have to do is build an antenna to acquire the signal. With the help of LARC, we have a club in our college, helped by the LARC club. With their help, we built a ground station which could track all LoRa-based satellites, which operates at 433 megahertz. We designed a 7-element Yagi antenna, right, with the help of Amarendra sir and Shashi sir, and we had this is a ESP based LoRa module capable of working as a server, and we interconnected an internet to it through an IoT technology where this could act as a server, and the person who is acquiring information or giving the satellites could act as a the client. So we were able to acquire packets from the LoRa based satellites which were there. Tiny GS. If anybody wants to build your own ground station, you could do that using this open source thing, and you can have a practice or the flair of tracking satellites with a reduced cost. All that it cost was around 3,000 rupees for us to build, of which the most cost is for the LoRa. The problem is we don't get that LoRa module along with the ESP module in the market actually. If you're able to get so, then you could try it out, track the satellites which goes over your home desk or over your house actually. Right, myself, Dr. Vasant here. Right, I've done quite a few of experiments and have been demonstrated, well validated. And if I have any other questions, I'd like to take it from you. Thank you.
Thank you, Mr. Vasant. And on behalf of LARC, once again, let's give him a round of applause. Thank you so much. Quick, okay. Before in the next session, couple of announcements. So, quick. Okay. As we said earlier, we are taking in orders for V3, micro BITX V3, available for 5,500, and we also have a few micro BITX V6 is available for 10,000 rupees. This won't be available at this price anywhere, and it's only at LARC that you can get it. So if anyone is interested, please go to the HF Signal LARC club counter and pick up the V6s or V3s. Also, we have the SSTV contest after lunch hours, and right now we have a session from Mr. Tariq, who is going to talk on home brewing drones, followed by a demo from him during lunch hour. So let's welcome Mr. Tariq. Okay, thank you so much.
The first problem. Okay, I'll start off.
this. Oh, no. I'll have to get another one.
Yeah. Just bear with me a couple of minutes while I set this up. This is the HDMI.
I'll take out this. Okay.
This is HDMI, right? I plug this in?
Yeah. One second. This. Right? Now this one, you use this. Okay? Which is that you want? Take your time. Okay? No problem. Slightly behind schedule, but it's okay. Yeah, I think it's charging.
No, it's okay. Yeah, so I don't know who gave the title Homegrown Drones, but I'll stay with that. Farhan did that, okay. So, yeah, we'll talk a little bit about drones. When Farhan first requested me to do a session on drones, I told him, Farhan, what's so interesting? I mean, you guys are building satellites and, all these fancy things. Who is interested in a drone? I mean, everybody sees a drone in a marriage function and in, political meetings and so on. So Farhan said, no. These are all techies. These are all geeks. They would like to know what goes inside a drone and what is needed to assemble a drone. So I said, okay, in that case, I can do a session and explain that. Now, my name is Tariq Hassan, and I've been an aeromodeling enthusiast since I was maybe 4 years old. And every time I used to go to a field to fly a plane, especially in the last 10 years or so, I used to see somebody flying, to see the drone go up in the sky and stay over there. And then after about a few minutes, they would land it and they would go home. And I would wonder what's so interesting about this. It cannot do aerobatics, you cannot do things that you can do with an aero model. So I never got into drones. But what happened is in the last couple of years, I thought, let me see what drone is all about. And I built my first drone and I was quite surprised. Because the amount of technology that goes into it and the kind of things you can do with a drone, you cannot do with an aero model. It's a completely different field. It has a lot of applications. And let me just explain to you briefly what is needed to assemble a drone or put a drone together. Now when I show people a drone several times and I say, see, I can take this off and I can keep it at a point in the sky. They say, what's the big deal? We see that happening every day. But the big deal is that when you actually assemble it yourself and when you program the drone and you make it do these things, it is a thrilling feeling that, you've achieved something right from scratch. So let us start off with broadly, what are drones? So drones broadly can be classified into two types. You've got drones that are fixed wing drones, and then you've got drones that are wingless drones. Now, of course, each of these has their own quirks. Each of these has their own applications. So we will not cover the entire spectrum because obviously we've got like 40, 45 minutes. So we cannot do the entire spectrum. But what we will do is we will just go through some basic pros, cons, and usages of fixed wing drones and wingless drones. Now, if you read the word, you can determine whether it's a pro or a con, or the usage. Now, obviously, under fixed wing, you have surveillance. Surveillance is a usage. Defense, military operations, these are all what drones are used for, fixed wing drones. Longer endurance, they can stay in the air for longer. Obviously, that's a pro. Heavier payload, that's a pro. It needs a runway, that's a con. Because in many areas, when you go to border areas, remote areas, inaccessible. You may not get a runway. So if it needs a runway to take off, that's not an advantage. It cannot hover. A fixed wing drone has to be moving all the time. If you make it stop, it will just fall out of the sky. So that's a con. It can run on fossil fuel, so the engine can either be a petrol engine or it can be an electric motor. On the flip side, on a wingless drone, again, you can use it for surveillance, military operations, disaster management, to supply medical food supplies, agriculture applications, to spray, fertilizer or insecticide or do these things. But it has a lower endurance because you have 4 motors or 6 motors running continuously all the time. For it to be in the air, the motors have to be running. You stop the motor and it falls down, right? So the endurance is lower. That is one of the cons. It can hover, a pro, right? It can reach difficult terrain. That's a huge advantage because in disaster management areas like floods or earthquakes and so on, you can take a drone and drop medicines and food packets and so on. So that is a definite advantage. And these drones typically, 99.9% of the time, run electric motors. But you have got a new type of drone now coming out, what we call VTOL drones. That is vertical takeoff or landing drones. So they can take off vertically, fly like a plane, and then land vertically as well. So this is the best of both the worlds. It can do what a wingless drone can do, and it can do what a winged drone can do. So it will have these vertical motors, which is used for takeoff and landing, and then it has typically a pusher motor to push it forward. And this is a very upcoming field. So a lot of people are getting into VTOL aircraft. Now, for the purpose of this session, we will limit ourselves to wingless drones. And in wingless drones, we will limit ourselves to quads. What is a quad? This is a quad, right? A quad is basically a drone with 4 motors. This is the most preferred format for hobbyists. So for people like me who do this just for fun, this is the most preferred format. And this is what we call a 5-inch quad. For a while, I didn't understand what this 5-inch meant. So I was measuring the length of the arms, I was measuring the length of the drone. But the 5 inches means that the diameter of these propellers is 5 inches. You can make a 7-inch drone, you can make a 9-inch drone, they come in various sizes. You can make smaller ones as well, nano drones. We heard about nano satellites, you can have nano drones as well with 3-inch propellers or even smaller than that. So we will talk mostly about quads. Now what is interesting about quads? What we can do with a quad, of course you can do that with other drones as well, you can do first-person view flying. So what is first-person view flying? First-person view flying means that you put a camera in the drone. So you see over here, there's a camera in front, okay? You have a transmitter at the back with a small little antenna. So it takes the camera output and it transmits it out. And then you can receive that video output on a set of goggles. Oh dear. Yeah, thank you. So what you do is, you place these goggles on your face, and you get this immersive experience where you feel that you're sitting on the drone. And then you can fly around, You get an excellent view of the countryside, you can fly indoors, go out of the door, come out, go into another area, all as if you're actually sitting on the drone and controlling it. That's really interesting. And racing has become a big thing now. So people put on these FPV goggles and they race each other. So you're given a track. So you go along the track and you race. You can do things like mission planning with these drones, which is also another so what I can do is, I can go into the software on the drone and I can set up waypoints. In the software that I am using on this drone, you can set up to 100 waypoints. And start a mission. You can start a mission by flipping one of the switches on the radio. The drone will take off, go to waypoint number 1, waypoint number 2, waypoint number 3. go to the final waypoint that you have defined, and then come back home and land. Completely automated. And that is something really interesting. You can specify what height to go to the next waypoint at a different height, go to the third waypoint at a certain speed. So you can define all these parameters, and the drone will follow that path, come back and land. So mission planning is a very interesting feature. You can do things like altitude hold. So during these meetings, political meetings and marriage functions, you see that the drone has taken off and it is staying at a certain altitude. It's not going up, it's not coming down. That is a feature on the drone. So you take it to a certain height, flip a switch on the radio, and it sticks at that altitude. So it knows now I'm at 10 meters and I should remain at 10 meters. So you can move it around, but it won't gain height or it won't lose height. You can do things like position hold. So I take it at a point and then I flip a switch and it stays there. I can keep the transmitter on the table and walk away. The drone will stay at that point. Okay? This is good for things like, surveillance and so on, where you want to keep an observation on a certain area. You can keep it on a position hold. Then you have return to home. So in return to home, you are flying the drone, and these are 5-inch drones. These are very small. Very quickly, you will lose sight of it. Even if you're doing FPV, sometimes you lose orientation. You don't know where you are. You flip a switch, and the drone comes back. It comes back to where you took off from, and it lands over there. I've got a couple of videos. I'll show these features, and we can also test it out if you have the will and the desire to see it. And of course, waypoint planning, similar to what I explained in mission planning. So, this is a navigation position hold. I was flying the drone and my wife decided to take a video of it. So you see, I'm not doing anything on the radio, but the drone is staying at that position. It won't move. Like a well-trained pet dog. And you say stay, and it stays over there. I think there's one more video. Yeah. This is an example of a return to home. This was probably my second or third attempt at return to home. So the first time I tried it, the drone came back and landed. I was very happy. Then I decided to do it between trees. I said I'll take the risk, because it has accuracy, depending on how many satellites the GPS has acquired, it will give you an accuracy of like 2-3 meters. So I went in between a clump of trees and I took off. And I said, let's see how closely it lands. So what I did is, it takes off. I let it fly away. And then I edited the video to make it short. So return to home activated, the drone starts coming back. And see, I'm not doing anything on the radio. I'm just holding the radio. It comes back and it lands right between the trees. Yeah. So these are interesting features. As techies, I think this will fascinate all of us. It doesn't impress my wife though. When I show her all these things, what's the big deal about all this? But so, if you want to build a drone, what are the parts that are needed? I'll just get a glass of water that I had kept here because my mouth is going dry. So, this is probably where the geeks will be interested. So if you want to build a drone, on the face of it, it looks like a toy, but there's a lot that goes into it. You need a frame, obviously. This X frame that you see. You need motors. For a quad, you need 4 motors. You need a flight controller. So if you look inside, and you're welcome to come and examine the drone once my session is over. There are 2 PCBs in this. The upper PCB is a flight controller. You get these off the shelf. So you don't need to go and build your own flight controller, although if you're really a geek, you might say, no, I'll build my own flight controller, but there's no need. I really believe if you want to enjoy a hobby, don't try to do everything yourself. There are components available. I mean, there are modules available. Just buy one and spend more time enjoying programming it and, doing various things with it, rather than trying to build your own flight controller. It is not so simple to begin with. So it is just time consuming, and then you're changing the hobby to something else, not building a drone. So you get flight controllers, and a barometer and an accelerometer are typically built into the flight controller. So you don't need to buy them separately. Most sophisticated flight controllers you get these days have got a barometer and an accelerometer built into it. Then you need an electronic speed control, because these electric motors that are running, you need to control the speed. So you need a speed control. And now you get speed controls with 4 outputs. So you can connect the 4 motors to the 4 outputs and control all the motors together. And typically, you know how a drone turns. There are no wings, so there are no ailerons, there is no rudder, so there is nothing to make it turn except for the speed of the motor. So if you give it a command to turn, it actually turns by varying the speeds of the motors. All that is done by the electronic speed control. Then if you want to do FPV, you need a video transmitter. So if you see my drone, at the back here, there is another PCB, which is basically a video transmitter attached to an antenna. So the drone on the whole has got 3 PCBs. There is a flight controller, there is an electronic speed control, and there is a video transmitter. Yeah. Then you need a camera, obviously, which you put on the nose of the drone. And then you need a receiver, because when you give a command from the radio, there has to be a receiver on the drone to receive that command. So you need a receiver. Then you need a GPS receiver and a compass. So obviously, if you're doing something like return to home, the drone needs to know where it is. So it needs a compass on board. So you put a GPS receiver and a compass, and then you need batteries. So these are LiPo batteries. This one is 1500 milliampere 6S. I have a slide on batteries, so we will discuss batteries separately. So on the left is the list of parts that go into the drone. On the right are the external parts of the system. So you need a transmitter. This is a transmitter, a radio transmitter. And you need goggles if you want to do FPV. Some people are not interested in FPV, in which case the goggles become optional. Okay? Now when you select a goggle, you have to be a little careful. I will explain that. There's a slide on goggles as well. So, and you can set up a earth station. So you can set up, a tablet or a laptop with directional antennas, so that wherever you are flying the drone, it is able to receive the video output and the telemetry information, and you can display it on a big screen. So you can set up a earth station, which is optional. So talking about each of these components, now these are frames. Frames can either be aluminum or carbon fiber, but carbon fiber is by default the material of choice. Again, you get this in the form of a kit. I see sometimes hobbyists, they'll buy sheets of carbon fiber and they'll start cutting it. Don't get into all that. There are kits available which come as a bag with full of parts, and you have to put it together like a jigsaw puzzle. So they'll show you an exploded diagram, and then you just figure out what fits into what, screw it on, and then you have a frame, something like this or like that. That is known as an X form factor. This is known as a dead cat. In cartoons, how they show a cat falls on the ground, and the forward 2 arms are more or less horizontal, and the bottom 2 legs are like a V shape, inverted V. They call it a dead cat form factor. This is actually a dead cat form factor. So it's not a true X. It has certain advantages and flight characteristics, but we will not go into that. Motors. So you need 4 motors. There is a whole choice of motors. There is so much of choice of motors that will just confuse you. And you will see that the motors are called like 2207. Like this, what I have used are 2207s. When they say 2207s, it means 22 millimeter diameter of the motor and 7 millimeter height of the motor. And there's a power rating. So for example, my motors are 850 kV. What do you mean by 850 kV? 850 kV means for every volt of power that you give to the motor, the RPM will be 1000 RPM. Now this is a 6S battery. So the voltage of this battery fully charged will be something like 25 volts. So 25 volts, each volt giving you 1850. If I run these motors at full power, they will run at about 40,000 RPM, which is a lot. I have never run them at full power, because if I keep it and I give it full throttle, it will disappear within like 2-3 seconds. You will not see where it's just gone. So you don't need to run them at full power, except if you are into racing. And motors typically run on 4S and 6S batteries. Now I have used 6S batteries, but you could very well use 4S batteries. What do you mean by 4S and 6S? 4S means 4 cells. 6S means 6 cells. And each cell will be 3.7 volts. So a 4S battery will be 3.7 volts into 4. A 6S battery will be 3.7 volts into 6. Flight controllers, yeah. So that's the brain of the vehicle. They include a barometer and accelerometer built into it. It is categorized according to the processor that is used and the number of ports on the flight controller, because every peripheral that you use, like a camera, a GPS, a video transmitter, these are all peripherals. Every peripheral needs to be connected to a port, right? And the default ports that are used now, that has become more or less a standard, are UARTs. UARTs is what? Universal Asynchronous Transmit Receive, right? It's basically a serial port. So when you are selecting a flight controller, you have to decide how many ports you want, how much memory you want, because you have both RAM as well as storage. The best thing you do is just go for the best controller that is available. Yeah, they can get pricey, it can cost you a little more, but you are future-proofed, because this is a very rapidly evolving field. A year later, you want to add another peripheral, you will have a spare port to do that. So, and these peripherals are generally soldered onto the flight controller. I know a lot of people don't like soldering, but you also get flight controllers with ports so that you can crimp on a connector and just plug it into the flight controller. So depending on what you prefer, you can select. There's a lot of choice of flight controllers. These days, the most preferred and the most powerful processors that are available are F7 and H7. These are the processors. Pictures of a couple of flight controllers. This is on the left is what is called a Maytech H733. This is a flight controller for a fixed wing drone. That is why you will see there are a lot of ports over there, because a fixed wing drone uses a lot of servos. One servo for every control surface. So for ailerons, you will have 2 servos. For flaps, you will have another 2 servos. For elevator, 1. For rudder, 1, and so on and reason. So anyway, so this is an electronic speed control, and you see it has got 4 ports here, right? So on each of these 4 ports, you can solder an electric motor, and the speed control along with the flight controller is called a stack. So these days what happens is companies sell them in the form of a stack. So you don't need to buy a flight control separately and an electronic speed control separately. You can just buy a stack. So you get a iFlight speed controller and an iFlight flight controller in the form of a stack, right? Both these put together will be in the range of about 12 to 14,000 rupees. And for the electronic geeks, you will notice that over here, you've got a filtering capacitor, right? 470 35 volts, because that is where the power is input from these powerful batteries, so you need a filtering capacitor. Video transmitter. Now video transmitters, basically you get of two types. You get digital and you get analog. What I have used on this is analog, because the price difference between an analog and a digital video system is huge. A good digital system will cost you in the range of 1 lakh rupees, and a good analog system will cost you in the range of about 15,000 rupees. So there's a massive difference. So I decided I'll go for an analog for now. This is what is called a DJI. DJI is probably the most popular company for drones as well as for these VTXs and cameras. This is the DJI system. This is the antenna. This is the video transmitter, and this is the camera, right? This is the LARC-6 analog VTX. I have not put a picture of the camera or the antenna on this, but the antenna is basically just plugged into the port, and this gets connected to the flight controller. The camera also gets connected to the flight controller, and you have a FPV system. This is an example. Obviously, a digital system will give you much better clarity. So I just downloaded a video basically from YouTube, where it gives a comparison between a digital output and an analog output. So you will see that the video on the left, although this is a YouTube download, so it's not very good, the digital systems are much clearer than this. On the analog side, you will not see much of a difference, because that is what the actual output is like. So you will see over here that there will be a lot of flickering, and sometimes, the video just goes away and then comes back around the corner and it's almost gone. Then it picks up again. Yeah, it is due to loss of connection. If you take the drone slightly higher, the connection improves. So with analog systems, a lot of time, we are just taking the drone up and down just to get a good video feed. GPS plus compass. GPS receivers in drones, I don't know how it happens in mobile phones or any other systems, but they are categorized by the GPS receiver that you have on the system. So this is using what is called a M10 receiver. M10 is now the latest. What I have on my drone is an M8 receiver. M8 receiver works fine. The only disadvantage I saw with an M8 receiver is that to acquire satellite, it takes a good 2-3 minutes. So you have to power on the drone, keep it on the ground, and just wait. Because until it acquires a GPS fix, it will not allow you to fly. The motors will be disabled. Only after it gets a fix that you can arm the motors and you can start flying. So that 2-3 minutes wait can be a little frustrating, but that's about the only issue that I find. The M10 system is supposed to acquire satellites much faster. And typically what you do is you install the GPS receiver at one end, either on this end or that end, because the further away you can keep it from things like power sources and metal, the better the performance. Goggles. Yeah, so again, depending on whether you are going for an analog goggle or a digital goggle, you have big range of goggles available. These are known as box goggles. The kind of form factor, what I am also using, this is a box goggle. They don't look very nice, but who cares how they look, right? As long as they perform well, this is an analog goggle. And then these are digital goggles. I think, in fact, this goggle is from DJI. Very, very good performance. Now, you have to be a little careful when you buy goggles, because this was my first goggle, and I didn't know what to look for. So I just browsed the internet and I just bought what I thought is best in terms of performance and value for money. But I made a big mistake. And I'll tell you what the mistake is, and it is so frustrating and irritating. I cannot wear this over my glasses. I have to remove my glasses and wear them. But if I remove my glasses and wear them, I cannot see the video very clearly. And more importantly, I cannot see the telemetry because you can configure the drone to send you a lot of real-time telemetry information. Things like your altitude, the power consumption, the duration of the flight, the number of satellites that are locked onto your drone. A lot of information. I mean, there's a whole list of parameters that you can enable and you can configure the screen. I want to show battery voltage here, I want to show this there. You can set up the whole thing, okay? And to read that, I need my glasses and I can't wear it. So the way I fly is I give it to my wife and she will be reading out the information from the screen. So, yeah, so I just ordered a new pair of goggles, which I hope to receive in the next 2 or 3 days. Now, you do get box goggles that can be worn over glasses. Yeah, they have a slightly bigger opening and they have slots on the side where these frame can go and you can wear them over glasses. But that is why you should always take advice from some experienced person before you just go and buy something. Batteries. Yeah, I said I have a slide on batteries. So the most common and the preferred chemistry is lithium polymer. And lithium polymer, as some of you will be surely aware, is not a very stable chemistry. If you mishandle the battery, it can explode, it can catch fire, it can melt, it can do all kinds of things. So you have to be a little careful. I have 2 friends during my aeromodeling careers who burned their homes. Okay? Because what they do is they buy some cheap unbranded charger and with these you use smart chargers. So you set the voltage, you set the power and you set the maximum temperature the battery can go to and all these things. And people are careless. When you're supposed to charge at a certain voltage or power, they increase it, they think it will charge faster and they end up burning their homes. So you have to be careful with them. You also get explosion-proof containers. So they just put a wire in it and you can keep the battery inside the explosion-proof container because otherwise it has to be monitored while it is charging. You have to be sitting over there or at least in the area and keep looking at it regularly, if that nothing bad is happening. Now these batteries come in, there are 2 ratings, 2S, 4S, 6S, 8S and so on, and a current rating. So like this is 6S, 1500 milliamperes. I could buy 3000 milliamperes, I could buy 10,000 milliamperes, but they become very heavy and not good for this drone. This is about the optimum size and weight that the drone can carry. And on this battery, I get about 8 minutes flight time. Yeah? So it's not a very long duration. So, and on the headset, I get the battery voltage continuously. So I know that if it goes below, for example, 20 volts or 19.5 volts, I have to bring it back. So my wife will keep calling out 21 volts, 20.5 volts, 20 volts. And the moment it comes down to 20 volts, I return to home and let the drone come back. You also have to be a little careful on how you store these. You should never store them fully charged. Say you're a weekend flyer, you fly on a Saturday or a Sunday, you come back and you charge the battery and keep it, they'll go bad. And how do you know that they have gone bad? They start swelling up. They get puffy. So the moment it starts swelling up, this battery is dead. And these are expensive batteries. They don't come cheap. Like this battery each will be about 3,500 rupees. So you can't, destroy a lot of batteries. So how do you store it? You store it by setting them on what is a storage voltage. So all smart chargers, they will have a program setting for LiPo, lithium polymer, and within that there will be a setting for storage voltage. So you select storage voltage and then you charge them. They will bring it to about 50 to 60% of the charge and switch off. And then you can remove them and you can store them. If you keep them fully charged, they'll go bad. Transmitters. Of course, like everything else, the trend is to use open source software. So this is a piece of hardware from a company called Radio Master. Radio Master is a typical Chinese company. And God bless these Chinese. They have made everything less expensive, so a lot more people can afford the hobby. This Radio Master is a fairly decent piece of hardware. The quality is quite okay. And all you get is the hardware. So you have to go online. And the most popular open source software for transmitters and receivers these days is something called HTX. So you go to the HTX website, download it, flash the transmitter with it, and then you have a very comprehensive, very good piece of software that you can, control your planes and drones with. The best thing about HTX is they support what is called Express or ELRS, long range system. So you can select how much power you want to transmit. Of course, the more power you transmit, the lower your battery life. But these batteries last quite a bit. I can do a whole day's flying, maybe 2-3 hours of flying on a single charge. So it's not such a critical thing. On 250 milliwatts, I get a range of about 30 kilometers, which is amazing. So, you go to a nice scenic place, like a lake or a valley or something like that, wear the headset and just go. And you can fly around the whole place with a beautiful view of the scenery. So it is a lot of fun. And they run over 900 megahertz and 2.4 gigahertz. This particular radio uses only 2.4. But then there are other radios like, for example, FR Sky and Fly Sky, which have dual radios in it. So you have a 2.4 gigahertz radio and a 900 megahertz radio. If it starts losing signal on the 2.4, it automatically switches over to 900. And 900 gives you a much longer range. So what software do you run? What software do you run where? On the flight controller. Flight controller, again, is just a piece of hardware. Again, there are many open source softwares available. Among them, the most popular are something called Betaflight, iNav, and ArduPilot. For quads, Betaflight is the most popular software. So, we have an aeromodeling group. On that, I was asking, when I built my first drone, what software should I use for a quad? And everybody said, use Betaflight. Betaflight is like the default standard. But I did not use Betaflight. I used iNav. Why did I use iNav? Because ultimately, what I want to do is a fully autonomous flight on a wing drone. So I should be able to keep my wing drone on a runway and just flip one switch. It should take off, it should do a mission, it should come back and land. That is my aim, that is my goal in life. And for autonomous winged flight, iNav is supposed to be better than Betaflight. So I thought I will install iNav and learn the software, because these are very comprehensive softwares and they're continuously getting updated. So I learn iNav, and then when I build my wing drone, which I will do at some point in time, I will know what to do. But the most powerful of all these is ArduPilot. ArduPilot is probably the software that is being used on the Chandrayaan rover, I assume, because you can use it for rovers, you can use it for submarines, for boats, for planes, for drones, for anything. And it's all open source. You get the source code, so you can do what you like with it. And I'm in a fix now. When I build my fixed wing, should I use ArduPilot or should I use iNav? But that is the fun of the hobby, right? You should have such good problems to solve. But for hobbyists, which I assume most of us are, any of these softwares are fine. You will be able to achieve everything that you want to achieve. Use any of them. Yeah, so that concludes my session. If any one of you wants to build a drone and you want me to send you a list of links where to buy things from or what component to buy, please send me an email or send me a WhatsApp message. I'll be happy to help you out. I was helped by a great gentleman from Pune when I built my first drone, and just merely pointing to the right link can save you hours and hours of headache, right? So if you need any help, don't hesitate, just contact me. Thank you, sir. I'm sorry I delayed you for lunch, but please Yeah. What we'll do is we'll fly the drone outside. So if you want to have a look at things like, altitude hold or position hold or anything, we can do it. How you want me to read it out? Yeah, 76720. 76720 74691. And my name is Tariq, T-A-R-I-Q. 76720 74691. Yeah. Thank you, sir. Thank you.
Thank you so much. It was a wonderful experience for all of us. In fact, it was really entertaining for all of us. And on behalf of the LARC, I would like to give you the certificate, sir. Thank you so much. I think we should start a local club here in Hyderabad with you as our...
There is an unofficial club.
Yeah, we should. I'll catch you. Thank you so much. We will now go in for lunch, and we have the contest immediately after the lunch. When we come back, after the lunch, demo will be now, then followed by lunch. Go for the demo now. Thank you all.
Now, you know how it happens in technology. Every time you want to do a demo, something does not work, right? No, the reason I am giving this disclaimer is that 2 days ago, I was flying the drone in my farm, and Murphy's Law, exactly. So that I had switched on return to home, it was coming down, and I realized it's coming down on a tree. So I wanted to switch return to home off, and by mistake, I disarmed the drone. So when you disarm, the motors go off and it just felt like a rock. So I picked it up and I cleaned it and all that. So after that, I have not flown it. So, sorry? Let's try. See, if it is not going to fly, it will not fly now, it will not fly after lunch. So.
Very informative, huh? Thank you.
I'm happy to spend time for.
Tariq, a few questions influenced me a lot. So when you said 50 milliwatts, it gives that 30 kilometers, right? 250 milliwatts. So I was just wondering about ये क्या कंट्रीज हार्टबीट पे चलता है because इसको कंट्रीज रहना पड़ता है, right? So that range, line of sight पे horizon से
So you can see the background over here. This is going to be a pretty interesting and interactive session. Hope you guys would enjoy. And my main goals are that I wanted to attract new SWLs in getting their licenses with VU2. If someone does not know what VU2 is, it is generally the license name that people give for Indian nationals. And apart from that, once people get converted or once people have their licenses, they generally stay inactive, especially the younger generations. So my target is for younger generations to keep them active. So I have to understand their pain points, what are their requirements, how they should move forward. So this is my target, and I would also be explaining how SSTV images or ham radio could be useful to others. Along with this, I'll discuss what interested me specifically in Amateur Radio Club. So coming to this slide, hobbies and interests. No matter where you go, these are the questions that you often get asked. If you're in school, your teachers ask you. If you're in college, your faculty asks you. If you wanted a job, interviewer asks you. And once you have kids, even they ask you. And I told the same thing to one of my friend, and he came back with another dialogue. So he was like, I'm done with my interview, bro. I'm having a job. I'm not interested in having kids. So how is it useful for me? Then I said that go to Tinder. The first question they ask you is, what are your hobbies? So whenever a person asks me this question, what are your hobbies? I just say ham club. And this is the kind of reaction that people give me, especially my friends. They think that I'm talking about hamsters. But that's not the reality, and this is how I look when they give me that look. But I clearly mentioned that I'm talking about amateur wireless communications. And I show them these images, and this is their final view. So they think that I'm a hacker, and then I can hack into phones and telecommunications, which is totally wrong, and I'm not that kind of person. And it's illegal to do, so that's a warning. So coming to the most important slide, why do you need it? So people generally give me this answer, especially the new hams, they say it for active communications. For active communications, you have WhatsApp, internet, SMS, which are pretty fast, and they store the previous information as well. But this is not useful. I mean, ham radio is not useful for active communications, but instead it's being useful for self-learning. It is used as an hobby, and especially for young researchers and students, it is useful for research and experimentation. And people would be able to gain technical expertise and do innovative projects. So, talking about SSTV, the full form is slow scan television. It uses the concept of frequency modulation in order to get things done. So, just to help you out, if this green color one is the carrier signal and the red one is the message, this is how the output would like, and this is what is called frequency modulation. If someone does not understand this, don't worry, the contest will be interesting. However, if I have to talk about the SSTV, generally images would contain pixels, and every line would contain approximately 320 pixels. And these are converted into gray values and then converted into frequencies of 1500 to 2300 hertz. These are then converted to audio signal and transmitted on the carrier frequency. And the same steps go back while trying to decode. So this is a simple slide about my future plans. My plans is to develop an app that could encode as well as decode Robot 36 and also ensure secure transmission of data. Currently, Robot 36 is open for all, but the secure transmission in the sense I might try to encode a secret message and I wanted to send it to only one specific person, I should be able to send it without any issues. Or I might need to send it to one specific community, I should be able to do it without any issues. And as I was mentioning, the whole point is to keep and host events in order to encourage new hams and make them stay active. So this is my acknowledgement slide. Thank you Amar sir, Shashi sir, and then Radhakrishnan, Thomas and Jilani sir for your encouragement. This would definitely be helpful in my career. So it's almost the time for the game. Like every movie starts with a disclaimer. Here is my disclaimer. It is placed in a safe location and it's easily reachable. So don't worry guys, it's not at heights. And avoid doing any damage to plants or property, especially if plants get hurt, I also get hurt. And the last one, play safely. So here are a few game rules. So the first thing I would like to say is that I would be transmitting an SSTV image that is suitable for Robot 36. So hope by now everybody has downloaded Robot 36 app, and once this image is being transmitted onto 145600, you would receive it, you can decode it using Robot 36 app. In that image, there will be some content as well. There would be something as message. Generally, you would have the LARC symbol, and then you'll have my call sign VU2JWB, and there'll be an additional message too. So I'll be displaying questions onto the screen for 9 images. For all those 9 images, the answer itself is the image. You need not mention what is written in the message. The answer would be whatever is there as image. Okay? I would be sending you one sample data also for you guys to check and check if everything is okay. If you have any questions, you can further tell me. And there is second level to this particular SSTV contest. That is, from all these 9 images, there will be few words that will be mentioned in the form of message. Generally, there will be a 1 word or 2 word. So when you combine all these 1 to 2 words in all the 9 images, you would get a sentence. That sentence would look like much more a tricky question. Once you understand the tricky question, you have to go to that place, get your chit. In that chit, you'll have some decoded message or encoded message. You have to tell me what is that decoded message. Or once you find that chit, you can come and tell me. I'll help you out with the remaining tasks. So you are allowed to use internet and Google like most of our generation do for everything, even exams. Sorry, my faculty. Screenshots are allowed, and generally Robot 36, if you're using it for the first time, this is for you guys. The image gets downloaded into the gallery by default. So whoever is participating, hope everybody has hams. You have your radio, right? Okay. So hope you have also downloaded Robot 36 app. The transmission will happen on 145600. So I'll be sending you one sample image. There's no question in it. It's just a sample image. Just try it out. So the SSTV treasure hunt contest officially begins now. Guys, forgot to mention one thing. If you know the answer, please do not raise your hand or shout from your location. Feel free to get onto the stage to grab your chocolate. So guys, if you have your answer, come up onto the stage immediately. As I said earlier, do not shout or raise your hand. Already first image is out and the image is... ఇంకో 9 images ఉన్నాయి, try చేసుకో. As I mentioned earlier, whoever comes onto the stage first will get the prize. So did everybody get their images? Is everybody ready with their images?
last question. Last question. Ready for last question?
Attention here. See, we are going to transmit the last image. But here the final thing is there, interesting thing. You have to club all the images and there's a clue in that. Whoever comes onto the stage with that clue, not a chocolate, we have a big gift for you. Keep it in mind.
There's a little prize money for it, and you need to identify the clue, go to that location, find the exit and get back to me. After this image, I'll get on the stage, but I'll be in the bath, okay?
Please come here only after completion of the image. Don't try to rush here.
The upcoming image is very interesting and is a motivation for many. So it's for me. So hope you guys enjoy it. Thank you guys for participating. This is my LinkedIn and you can see the feedback form as well. You can take a picture of it and get in touch with me whenever you guys are free. The images are out. You have a clue. Based on clue,
ఏదో రాశారంట అది కనిపెట్టి 20 ఉంటే సార్ వదిలే
show you the images. Whoever is interested can look at the images. Guys, I'm responsible now. Who got that check? No, No, someone has to get the chip. There will be a chip there. Someone has to get the chip. There will be something to decode in there. They have to decode it. Wireless communications and children. So every image has one thing. I am hungry throughout the day, comma, but glows. This is actually glows if I open the image, it glows. But glows during the night. Something is there outside, or it could be inside also, I am not sure. Based on that, people have to find the check. In that check, there is a Morse code to decode actually. There is a real-time Morse code. Once people decode the Morse code, they'll get the final answer. If they tell me the answer, they'll be considered failures. My dear fellow friend has got the check. Congratulations, bro. What's your name? What's your name?
Manish.
So Manish from Dindi School has got the check. So Manish, read what's the heading.
Decode the following and let VU to JWB know the answer.
So we have a Morse code over here. Once he decodes, he'll tell me the message. Meanwhile, we'll let the other sessions continue. So Manish, you have 5 minutes to decode the message, otherwise we'll give it to someone else. Manish, your time has already started now.
Happy New Year.
This is absolutely good. We know actually.
Only 1 minute is down, guys.
60 seconds forward.
I need all the letters. Local letter march better. Letter march better. All the To all the new hands who have taken radios, could you please give it back to the respective people?
This is very bad. Looking what is here and what is here. This one. Sir, చెప్పండి. Jelani garu, students are very bad in this particular. We forgot, sir. Tell them to your CW class regular. Notes code T and notes code D code.
Sir, use.
By the way, my friends, Manish has come up with his answer. Here was the check. There was a Morse code inside it. Whoever has not learned earlier. What does it say?
APJ Abdul Kalam.
That's it.
Thank you, Ravi Teja, for this wonderful engagement of young minds. And that's a very novel idea of hooking all of these people to amateur radio. That's a wonderful this thing. On behalf of LARC, please.
Thank you, sir.
You have both the participation and the speakers. Thank you. And we will keep the prize money for some time. I'll give 10 minutes to Amrendra sir. He wants to say something.
So thank you for your participation, dear friends. See, I have a good information for you, which is very interesting for the students, because all the youngsters are participating. Sorry to the old people here, they might have thought something else. See, there's so many things are clubbed into this event now. You can see physical exercise running here and there outside. That old people could have not imagined. One thing. Finally decoding a CW message. That is one more thing, disastrous thing for the people who don't know CW, and people have already got licenses also. I saw some guys just now only checking the pages, what is A and what is B in the coding and all. And you have to think about it, and there is some work to be given to your brain to think about the clue also given in that. Like this 4 or 5 varieties of these things are clubbed into this single event. Now, this is the information for the youngsters, especially it's very interesting for the students. The polytechnic and school students or engineering students. Now, these sort of SSTV images are on schedule transmitted from the International Space Station. Very interesting for you. Listen here. You may be engineering students. It doesn't deviate from the subject. Very interesting for you. International Space Station, occasionally with a schedule announcement, prior schedule announcement, they transmit the images as per their schedule from the ISS. That schedules are well in advance, and 1 week in advance they will announce on the AMSOT web page. You go through them on 145, 800 frequency, or they'll give the frequency also in that. And the International Space Station passes over your area that keeps transmitting those images. Normally it takes 24-hour schedule time, continuously various images they transmit from there. So in 24 hours, how many passes it goes around the earth, those many orbits, they continuously transmit on that frequency. That you have to download with your, because signal strength from the International Space Station is very good. Even if the walkie-talkie with a rubber duck antenna is quite sufficient. Something like here only. You sit out in your balcony or go onto the, this thing onto your rooftop or somewhere onto the terrace. Just hold your antenna and hold your mobile phone like this, and the images, whatever is sent from the ISS is copied onto that thing. Whoever sends that images to the AMSAT web page, get an immediate certificate with your call sign and everything written on that from the ISS. Can you imagine this thing for an engineering student receiving a certification from ISS? Have you ever heard of this thing? Any of you? So listen carefully. This is a very easy thing. It is an encouragement for the young students, especially the students and youngsters also. So it's very easy, very simple thing. You copy that while coming from the ISS. You can hear the same station, this thing. You just download the Robo36 software into your app into your mobiles. Listen to that thing. It keeps on making the sound. And while it making sound only, whatever you have seen here, the same way the image forms clearly. So if your signal is clean and you are capable of catching hold of the signal, clear signal from the ISS, beautiful pictures, mostly astronaut pictures, related to the space, and these pictures only are transmitted from the ISS. So you get that image, those images you can immediately send through a mail to their AMSAT website, the mail address. You will automatically get a certificate from them saying your call sign, your name, everything on that. Are you not pleased with that? Is it not very interesting for you to get certificate from ISS? Is it or not? So that's the information. See, this is an exercise, a beginning exercise for you people. What is SSTV, slow scan TV images, how they are transmitted, how they are copied, how they are decoded, and what you are going to get out of that thing. This is what we wanted to exercise here. That's why first time we have planned this event here in this Lamakaan 6th edition. Thank you very much. So all guys keep in mind, schedules are there on AMSOT website, how ISS, as according to their schedules, how they are going to transmit, when they are going to transmit the SSTV images. That will be very interesting for you. And you will get a certificate. That will be very interesting to you. Thank you.
From the so we have a first prize, the only prize in fact, and it's a cash prize of 2,000 rupees for Manish. Let's give him a big round of applause. Sir, you only give that.
This old boy is from Dindi School.
Dindi School.
Model School of Telangana government. I have seen these guys are doing a very good job here in these events also. They are very, very fast and very active and very smart also. That's what I'm seeing from all these boys from Dindi School. And anyway, we have all the appreciation for the instructor. Thank you.
Thank you so much. Okay. Okay, now a special award. Amrendra sir, please. Here, I'll call it. Ritvika, please come on stage. One of the youngest AMs here, who is regularly participating. Come on stage. Shashi's this thing.
Actually, her niece.
I know.
Wow.
Hello. Okay. Yeah, take it from another Tata.
Here,
take.
Good.
She's Ritvika. She is actually our Shashi's niece. So she is very eager to be a ham. Take it from uncle. Yeah. Let's all give a good clap. Thank you. Thank you.
Would you call whoever got the answers or chocolate here onto the stage?
To have a group over. Yeah. Those who got the chocolates. I'm not asking for the chocolates. You must have already.
All the kids who got the chocolates, please come onto the stage.
Who all got the chocolates? Kindly come here. Not for your chocolates. Only for a photograph. Please.
Please come on stage. Before I do that, anyone has come with their home brewed project? Can I see your hand? Anyone? Okay. All of you come up. Come in the middle. Come in the middle. Hello. Yeah, come in the middle, please. There's one chocolate for me, huh?
We'll give it to Rajvika.
Okay. Come. Come. There's another younger one I noticed now. You, sir, there's another small thing. You give her this chocolate. Come. There's another. Wow, come here. Yeah. Wow. Can leave the old man out.
Odd man out.
The old man out.
Okay. Thank you.
Thank you. Any school going kid or college going kid who needs a participation certificate, please come and meet us. We have already given to most of the students participation certificate, but those of you who are here and who need a participation certificate, contact RK. Here he is. Okay? Participation certificate. Okay? Anyone needs, please come and sing. I think even Nathan can come and take one. Okay? Anyone else? This is applicable only for school children and college going children, not for others. Now, this is more or less an open house. If anyone wants to come on stage and talk for a minute or so, you can please come up, share your experiences or whatever you want to, any feedback, you can please come up and share the stage. Yeah, you can, one of you can come up and speak. See, not, you can speak in Telugu also, not an issue. Okay, come. You want to speak, huh?
No. Just, I'm engineering student.
Okay.
Is it okay? Hello everyone who are sitting here. My name is Visalakshi. I am from GMR Institute of Technology. Currently I am pursuing my internship in NIR College, NIR office. It is National Institute of Amateur Radio. And before that, I don't even know such type of activities, such kind of ham events and all. And here are our faculty, here are our co-officers who encouraged me to participate in these events. And today I learned lot of things, new things I have enjoyed in participating the event, SSTV image and all. It is a good privilege to participate and meet new hams everywhere. And I also want to take the call sign, I want to take the ham exam. So I am thanking my faculty, Jose sir, Mukesh sir, Srinivas sir for bringing me here. And I enjoyed very much. I thank all the event organizers who gave me participation certificates and they encouraged me to participate. Thank you very much for giving this chance.
Just 1 second. This one you're talking on or Wi-Fi? We will just, there you have to find out. Anyone else would like to come? Introduce yourself and then.
Good afternoon to one and all. I am Harshavardhan. I came from Dendi, Gundlapalli from TSMS Model School. Jilani sir take me and our friends here. Since I came here twice. We took 3 projects. One dustbin and other temperature weather station and radar. a lot of members visited us and asked a lot of questions. We experienced a lot by answering the questions and learned a lot from that questions. And today we had participated in a treasure hunt and we saw the result. I felt so happy and I enjoyed a lot by participating here for 6th Lamakaan convention. Thank you one and all.
Thank you. That was sweet. Anyone else? Okay.
Good evening, everyone. I am Syed Adil from Dindi. My call sign is VU3YEC. I am very interested in this kind of organizations and programs. So that's why I came and took permission from the college. I loved the questions they asked, everything they have been being with us. And I want to thank everyone. Thank you.
Anyone else would like to come? Come.
Good afternoon, Mandivnal. I am from Nalgonda, Dindi, Gundapalli, TSMS Model School. I study in a government school and I made 3 projects according to the weather and the smart dustbin and radar. What I felt is the judges are so friendly and they challenged me very hard, sir. If I would get a chance now, I can explain well. And I challenge, in the next LARC-7, I will perform best. And it's my promise, sir. Thank you.
Well, the time has come for us to say bye for this year. So we are really thankful. It is people like you who keep, making us come back every year and contribute more for amateur radio. And this time has been very special. We were wondering actually whether we would get even this amount of crowd, because it was very close to the HFI. But still, it is a great privilege that there were almost 350 registrations which we had. And really it has been a wonderful time. So we thank you all, for all those who especially came from far away and made this event a memorable one. We thank you all and we hope that you go safely back home, and we will see you for the next LARC event. Thank you one and all.
Sai.